We've mapped it onto the Carnot map. If we wanted to, we could have had A on this axis and BC on this axis. We still would get the same outcome. Now, for Carnot maps, the ruling is that you have to group them in anything to the power of 2. So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So we can have groupings of 1, 2, 4, 8, and so on. And the other rule is that you can group them up, down, left, right, but never on the diagonal. So if we look at this grouping, there's only 2 possible groupings that we can do. This one here, and this one here. Now, how do we extract a Boolean expression from this? Let's look at this blue circle. We can see that it has AB, but it has complements of A. It has a 0 and 1, which means we can ignore A. We have to include B, and because B is high, it's just B on its own without a bar on top. The C value does not have a complement of it, so we have to include it, and it's just a high. It's C without a bar. This grouping here is B and C. Let's look at the next grouping here. We have 1, 1 and 1, 0. B is complemented. There's a 1 and a 0 for it. So there is no B term. The A term is a high, so it's just A. And similarly as last time, it's just a C on the other side. We have to OR all of these groupings. And this is the final expression we're left. We can build this logic circuit if we want, but we can extract a little bit of Boolean algebra. C is in common in both. And voila. Let's draw this circuit out. Do what's in brackets first. We OR A and B. We AND that outcome with C. And this is the logic gate that we would need to construct to make our Jurassic Park problem work. A little bit of a humorous problem. I understand that it might seem a bit silly, but the concept can be applied in any real life when you work in a lab or in any infrastructure or security systems or little beepers and conditions that you need in your car to ensure safety. All of these come down to a simple logic gate that you need to construct out of a truth table. Happy logic gating. Bam, bam. Hello. Hello, everyone. Oh. Got something stuck in my eye. Nathan's banging all the doors. I'll close my window in a second. My door, I mean, not window. Do we have City Skylines music playing? We do. It's just very, very quiet. Nice City Skylines music. Thank you, Ocean. Welcome in, Dan, Harry. Hope you guys are having a wonderful Monday. I'm just going to post that I'm live on YouTube really quick. Link. Go. Oh, fuck. I posted the link and I accidentally deleted it. But, here we go. Well, solving Pulley problem. There we go. Posting on my story real quick. Done. There. Hi, Simplex. Welcome in. Welcome in. May the 4th be with you and also with you. Hello, Zier. Hello, Not the Brain. Welcome in. Happy Monday, guys. It's freaking Monday and I'm streaming on a Monday. Imagine that. Imagine that. Let me know if the soundtrack is a bit too loud. I'm playing, where's my lip balm? I'm playing City Skylines music. It's epic, but, you know. In today's economy, streaming on a Monday, I know. I actually looked at my Twitch tracker recently. And it shows that I'm only streaming like 40 to 45 hours a month, which is really little. You know, that kind of streaming hours, you wouldn't be really growing your channel. And surprisingly, not only am I stable, but actually growing a little bit. I'm really lucky. But long streams, it depends. I always think that my streams are never that long. To be fair, I look at people like Slow and Ultrasaurus who stream like 10 minimum to 15 hours. So maybe I'm looking at other people. Hi, in City. How are you so consistent? Give me some tips. What do you mean by consistent? Like streaming or? Sound seems fine. Nice. Thank you. Thank you, Harry. Quality over quantity? Like, I'd like to say that, but I don't know if it's fair to say that I do quality stream. What does a quality stream even mean? It's hard to know. Yeah, streaming. I've been streaming for years. It's 6 years, over 6 years now. And I was inconsistent. Sometimes I was consistent. Sometimes I streamed a whole lot. Sometimes I don't. Like many things, it's discipline, I would say. Everyone says like, oh, do a job that you love. And you'll never work a day in your life. But the reality is, I love my job, but I do work. Sometimes, most of the time, it is work. More than anything, it is about consistency and about discipline. Most times, half the time, you're not going to want to get up and do it, but you got to do it. Bank holiday Monday. It is. It's a bank holiday Monday in Ireland. That's why I'm streaming. But also, the semester's over as of last week. The semester is over. I still have to work, but I can definitely afford, if I just jumble my schedule, to do one weekday stream. So let's pull out all our calendars. Everyone pull out your phones, get your calendars out. Let's have a look. What day should we stream next week? Weekday specifically. Double pay for today. Oh, for working today. Okay. I was like, wait, does that mean I get double money on Twitch today? Do you force no, two very long semesters. From September to December, and then from January to May. Ah, pachinko, nice. Nice. So let's look at the calendar. On Monday, I have program meetings. On Tuesday, I have Bambi. Oh, I have to stay home on Tuesday because of Bambi, actually. There's a next Tuesday is a day I have to stay home anyway because I'm taking Bambi to the vet. And I want to babysit her. Make sure she's okay that day. So I might stay home on Tuesday. Tuesday might be the next streaming day then. There we go. I'm inevitable. 295 stream streak. Let's go. Are you yanking my chain? No, because the chain is not massless. In this case, it's a frictionless, weightless rope I'm yanking today. String. Is it string? I don't remember. What is it usually in those problems that they describe? Is that ketchup on my chin, or is it just pimples? I think it's just pimples. It's so pimples. Hi, Code. Which physics branch is your favorite? Thermodynamics, I would say. If I had to choose it, yeah. Oh. I want to play City Skylines now. God damn it. But when I was playing FTL music, I wanted to play FTL. When I was playing Surviving Mars music, I wanted to play Surviving Mars. Oh, god damn. Also, day 17 in a row of fishing accomplished. Zero fish caught. Aww. Yes, I'm going to pull out the whiteboard and we're going to do some proper pulley problems today. The reason is because last year in the Irish Leaving Cert, a really interesting pulley problem was asked, and I want to solve it and upload a video on the topic. But I haven't done pulley problems in years. So, there we go. Hi, Herder. How are you doing? Welcome in, sweetie. Do you currently look for a PhD student? I did apply for funding. I didn't get it. But yeah, I'm always looking for funding and applied and PhD students. But in this case, if a PhD student approached me, they have to bring funding to me. That case. The soundtracks are, aren't they though, Harry? Aren't they? They're so freaking good. I have no idea what you just said, but I'm excited to learn. So pulley problems are classical free body mathematical problems. It's this idea of a block moving up or down, but instead of free fall, like, you know, just dropping it, there's tension, there's rope attached to it. So more than anything, it's kind of like elevator problems that we're going to do. So that's what we're going to solve today. We're going to start with some very basic ones, and then I'm going to pull out all the exam papers from the previous years in the Irish curriculum. Because the problem is I don't mind making up problems, but I haven't done this in so long, I might need a bit of revision. So I would like to pull up stuff that I at least had the answer to. So I'll quickly check if I did it correctly. And if I didn't do it correctly, we have to sit back and solve it. So if anyone is ready, you're going to have to check my maths today. Today is check the tofu maths day. Exactly, dynamic problems. Hi, Chris. Agnes. Speaking of Surviving Mars at the moment it's Paradox Interactive is the studio, not studio, publishing house. I just opened Steam and they're on sale. Those dudes, oh my god, my English, what the hell is wrong with it? There's a sale at the moment. What's the proper meaning of Shilia? I actually don't know. Oh, I didn't know that word. So apparently it's a walking stick and it's called a willow thong. It translates as a willow thong. Don't know if that's true, but yeah, that's interesting. Today I learned. Okay, Shillelagh? Okay, I've never heard of that before. It's a walking stick that's sturdy. That's a very Irish thing to say. Yeah, I've never heard of that word before. Today's a new day for me. Well, as they say, or as I say, or as others say, every day is a school day. Today we learned something new. Hi, Spin, welcome in. My chains are attachable, so I haven't been wearing the chains lately. I'm not sure why. I like them with the bigger glasses, but yeah, I've 3 pairs now, 3 functional pairs. I have this one. I like these ones. These are my favorite, but I think statistically these are the ones that everyone hates the most. Then I have these ones, my grandma glasses. I have my grandma glasses, I don't even know what to call these ones. And I guess these are Harry Potter glasses. Don't know what else to call them. Jesus, they're so dirty.
Welcome to Rivendell,
Mr. Anderson. Hi, Tarek. How are you today? Welcome in, welcome in. How ya keeping? Hope you're keeping well. It's one of the spells in the... Oh, is it? That's cool. Yeah, I was looking at Paradox there for a second. Do you remember I said I love Surviving Mars? But there was that relaunched that happened. Relaunched Ultimate Edition. It's on sale at the moment. Now, the question is, do I buy it? Apparently, it's trash. Is the Surviving Mars relaunch trash? As people make it out to be. And thank you again, Tarek, for giving gift sub to Kiri. I really, really appreciate it. Thank you. Yeah, glasses are cool. You might refund it later. Is it that bad? Hi, Kip. Welcome in. Welcome in. Oh, I hope I'm not an idol. Don't idolize me. Goodness no. I hope to inspire, but don't look up to me too much. I did nothing of what's the word of yeah, I didn't do anything that great in life. Hope to inspire a little bit and motivate people. That would be the best thing to do. 60 stream streak, let's go, herder! Hooray for recreational plutonium! I was just thinking about it today, Spin. That's why I'm kind of a bit alarmed about it. Just that I did used to have people I looked up to, and people who I idolized and stuff before. But do you know that figure of speech of don't meet your heroes? I had that happen to me a couple of years ago, and I got an opportunity. Yeah, and kind of, do you know what it needed to happen? It needed to happen, and I've really fixed my view on these things. I get inspired by people. I really look up to some people in some shape, way, or form, but I never like, okay, no, I don't actually look up to people much. Yeah, I'm just a bit careful about that now. We have plenty of time yet. I posted as well, by the way. Huge thank you to everyone watching my YouTube. I'm so glad to see that it's going really, really great. We are 300 watch hours away now from being monetized, which is insane to think about. And YouTube is like 5 days delayed. So from 5 days ago, we're 300 VOD hours behind. So if everything goes well, there is a chance that, you know, I could be monetized in 2 weeks' time, if not less even. But yeah, huge thank you to all of you guys supporting the YouTube channel. It really means a lot. If we get monetized, that means for the first time after years and years, of doing the social media content that I do, I'm actually getting paid for it. All the videos that I edit and upload for the first time. That would be so exciting. Yeah, getting inspired by what to do is great, but after all, everyone is exactly, Tarek, exactly. And some people, I think that we need to reflect on is that on average, okay, maybe this is wrong, but most people are actually good people. Okay, maybe I'll take that back again. In my community and in my vicinity, most people are good people, but they've done bad things to me. Even people who I call like, oh, that person was an awful person, like if I say that passively. But what's really important to know is that it's just probability of interaction. You know, you could be one of the best humans in the world, but you just had a bad interaction with another human being, and they think you're the most evil person in the world, and that's just statistical probability, you know. And I need to kind of remember that, and I need to let go of that a little bit because I'm such a people pleaser. I tend to forget that. Listen, thank you so much for your prime. 58 months, let's go. Can you tell me your favorite quote? E possi move by Copernicus / Galileo. It's debated on who said it. Watch time zone, BST, British summertime. Not to be confused with IST. I always say IST, Irish summertime, but apparently that is actually considered the standard Indian summertime, so that's why I tend to say it that way. Elizabeth, welcome in. How are you doing? Welcome in, Donut.
Dude, Ray, what do you want to do tonight?
The same thing we do every night, Pinky. Try and take over the world.
Ah. Yeah. I am wary. Don't idolize anyone. We're all human. We make mistakes, but rather get inspired and get motivated to do things. If money was never a problem in life, what area of theoretical or applied physics would you study under curiosity? Ooh, under pure curiosity? I don't know. A good question, but I don't think I have an answer. Sorry about that. There's Eastern Standard Time. Ah, that is right, yeah. Get cracking. Should we get cracking, lads? Have we a lot to do today? We do have the pulley problems, like I said, something that we want to solve. I don't actually have textbooks on it, but what I do have is the Irish exam papers. So examinations.ie, I think, is the website, the official website. Is this, now that I think about? Irish exam papers. An official government state exam. There we go. State examination. Exam papers. Oh, 2026 exam papers are already up. Wait, did they start sitting for exam? Wait. Leaving certificate. Applied mathematics. Ireland. Okay, so we're just gonna. Oh, this is so annoying. Have to like. It's not done by subjects, it's done by year. So if you want to. Version. You want to. Oh, did I do Oscuelga accidentally? No, I didn't. We'll look at the last 3 years of the applied physics paper. Applied mathematics. I just found your YouTube. I'm glad. Hopefully you find it a little bit educational. Obviously, I don't want to bully everyone. Watch my YouTube video. Get me monetized. It does help, of course. But obviously, if I help you out in some areas and stuff, that would be great. It really means a lot to me. The watch hours. We're so close to being monetized. Then we'll take over the... That was my goal over the summer, to get monetized. And if I achieve my goal before I properly start streaming over the summer, I need another goal over the summer, chat. What we need, if we achieve the goal, we need a new goal over the summer. Even the monetization thing is a goal that I don't tend to try and do, usually for myself. Bunny standard time. Star 415 stream streak. Let's go. It's the science YouTube. It's the science YouTube channel. Hello, John. Welcome in. Where was I? Oh, I got distracted. Damn it. Oh yeah, what goal I wanted over the summer. Hello, Eagle. Welcome in. There is still world domination. World domination is a big project to get done over the summer, Kip. We're always moving towards world domination. But yeah. What I was saying is getting monetized, or like achieving a follower goal, or like VOD hour goal, those kind of things are really, really bad goals. If any of you guys are making content creation, and you're setting yourself goals of, I want to reach 100 followers, I want to reach 1,000 followers, I generally think those kind of goals are not very good, and I try to stay away from them usually. What I recommend, if possible, is say something on the lines of, I want to upload 3 videos a month, or I want to improve my editing skills and have an average upload of 2 videos a week. Or I want to dedicate 2 hours a week to editing. Those goals are a lot more, first of all, doable, and you don't have like a heart set to something that you can't control. You can't control how many followers you're going to get. You can't control how many people are going to view your stuff. So I became a lot less attached to a lot of my goals once I stopped doing those kind of goals. Stop doing follower goals, subscriber goals, those kind of things. A lot happier. Something actionable. There we go. Exactly. Set goals that you have full control over it. There we go. Hi, Stephen. Welcome in. Make some videos on the JEE advanced physics problems. I looked at some of them actually earlier. They're quite challenging. I don't know, but so many people have made so many videos already. I wonder if there's any use to me. And what about very old friends? Lint, thank you so much for the tier 2. 28 months. Thank you. I'll guess you'll watch me after call. So I just downloaded a whole bunch of papers. So I've downloaded exam paper 2025. We're looking at the Irish exam paper. 2024. And 2023. Now, what's fascinating about this is that the exam paper has actually changed significantly since I did it. Oh my God. We don't actually have a pulley problem 1 year. Oh, wow. That's mean. Man, applied maths is so hard. It's so unpredictable, this paper. Maybe we'll just do 2 years then. And I have the marking scheme as well. Now, the marking scheme is terrible. It doesn't actually give you the equations or the answers. Sorry, it doesn't give you, like, you know, proper derivations. It just gives you the answers. But at least if I'm doing it bit by bit, I can check my work and be like, oh, I did something wrong here. Let's go back and try and solve it. So that's the goal today. There we go. Exam paper for who? This is the high school graduating paper in the Irish curriculum. The subject is called Applied Mathematics. It is not mandatory. In fact, it's one of the least popular subjects taken, and it's considered one of the more difficult ones to take. It's not that it's quite hard. A lot of people sit and it's like, oh, this is not too bad. The reason why it's considered hard is the time investment ratio. There's so much to learn. There's so many different topics to cover, and you have less than 2 years to cover it. While other subjects build on other modules, for example, if you do geography, you can take Leaving Cert Geography and you build on the previous 3 years that you did, and so on and so forth. Because applied mathematics doesn't have a previous subject, it comes out of nowhere, and students have only 2 years to study it, and it is quite hard. Hi, Cami. Welcome in. Welcome in. So this would be considered a high school level. 16 to 17-year-old, yeah. So you'd start this curriculum at 16, yes, and then you'd be sitting the exam paper at 17 or 18 years old, yes. No, that's the thing, Pachinko. What's really unfair about that subject is I think you can verbally discourage students from taking the subject, but there is no requirement to have needed higher level maths or something like that. And you don't need to do physics to do it, but it's almost like you're shooting yourself in the foot if you don't. It's quite like, it's one of those subjects. So we're going to look at the exam paper. I'm going to show it to you. And just imagine that sitting this, you don't need advanced maths and you don't need physics. And so it looks a bit like, and try to look at it the lens of you being a 16-year-old. Okay? What were you like when you were 16? Hi, cynical sources. No calculus, right? In fact, calculus is in it. That's controversial, Chris. So the Irish Leaving Cert curriculum says, maybe this has changed, but back in my day, you couldn't have calculus on it because it wouldn't be fair to students who happen to be doing past maths. You have to give the option of physics without needing higher level mathematics. Applied maths doesn't have that. It is a passive requirement to know calculus to do it, even though no other subject in the Leaving Cert requires you to do so. I think that's really unfair, but you know what? It is what it is. It is what it is. Sure, it's life. The problem with it is, again, like, why would students bother doing applied maths when the system in Ireland is about the point system? So they're way easier subjects to do to guarantee yourself an A or a B over applied maths. Applied maths is extremely difficult to predict. You really do need to be knowledgeable and study a lot. And it's just an inefficient subject to do. Yeah, okay, I'll show you. So the applied maths curriculum has changed since I was a student. So what year did I sit this? It was 2013. I'll show you what a 2013 Leaving Cert paper looked like. Just to show you what it is. So imagine you start studying this at 16 maybe 15, 16, and you sit the exam paper at 17, 18. There we go. You have 2 years to study all of this. And you don't have any physics. Bear in mind, you do not have any physics. This is the paper. All right, we'll have a look at it now. Programming. No, we're not looking at Steam. All right, here we go. Oh, this is the marking scheme. Shit. Sorry, wrong paper. This is the answers. 2013, Lehman Cert applied. Applied mathematics. That's the wrong paper again. There we go. Okay, so here we go. This is the exam paper I sat when I was 17 years old. So we'll have a look at it now. Well, that makes everything easier after seeing the answer. That is true. A suggestion after this. Can we also take a driver's license exam? I don't think so. I think it's copyrighted, Kip. It's a subscription based. I think legally I'm not allowed to show you a sample exam of the Irish theory test. I looked into it. It would have been nice to practice some studying on stream for my theory test. But yeah, I don't think I legally am allowed. All right, so I sat this exam on Friday, 21st of June, 9:30 to 12 o'clock. So you have 2.5 hours to sit this exam. Take the value of gravity to be 9.8. Marks may be lost if necessary work is not shown. 6 answers need to be answered. 6 questions. Okay, so question 1. A ball is thrown vertically at a speed of, usually question 1 is a nice question, right? Of 44.1 meters per second. Calculate the time interval between the instance of the ball is 39.2 above the point of projection. Really nice and easy, kind of slipping you in. It's about, equations of motion, throwing the ball up and throwing the ball down. You can do the, get a quadratic for time. Get it out that way. It's not too bad. Ah, thank you so much for the 195 streak. Welcome in, welcome in. We should have a warning on the stream. Trauma warning for people. A lift descends from rest at a constant acceleration f until it reaches a speed v. It continues at the speed and then decelerates uniformly to rest. The total distance ascended is d and the total time taken is t. Draw a speed time graph, show that v is equal to this and show that t is equal to this. This is tedious. This is a lot of algebra, but it is quite tedious. Could you zoom in? Yeah, sorry. Here we go. Is this considered an easy question? The question 1 would be an easier one, yes. It's kind of a question that to ease people in. 55 streak, let's go. So there's about 10 questions here, or 9 questions. I would have done question 1. Question 1 would have been the easier one. It is hard though. The stress is that you're not going to get this and it would be just, just absolutely terrible. Two cars, A and B, travel along 2 straight roads with an intersect of an angle theta. So this is a car and this is a car. Here we go. We're literally studying for my driving test. Car A is moving towards the intersection at 9 meters per second. Car B is moving at the intersection at 15 meters per second. At a certain instant, each car is 90 meters from the intersection and approaching that intersection. Find the distance between the cars when B is at the intersection. If the shortest distance between the cars is 36 meters, find the value of theta. Quite a tricky question. Again, we've never practiced a question like this before. This came out of the blue. Really, really troublesome. An aircraft flying at 600 kilometers per hour sets out to intercept a second aircraft, which is a distance away in a direction of west 30 degrees. Find the direction in which P should fly in order to intercept Q. Jesus, this is like dogfighting. Quick mathematics. Quick mathematics for dogfighting. Question 3. A particle is projected from a... Okay, so question 3 is definitely a question I would have done. So question 2 is a question mark. I might not have done question 2. Question 1 I did. Question 2 I did not, maybe. We'll see. Question 3. A particle is projected from a point on a horizontal ground. The speed of the projection is u meters per second at an angle alpha to the horizontal. The range of the particle is r, and the maximum height it reached is r over 4 root 3. Show that r is equal to 2u squared sine alpha cos alpha over g. Find the value of alpha. Geez, this is rough. A plane is inclined in an angle of arctan half to the horizontal. A particle is projected up the plane with an initial speed of u meters per second at an angle of theta. The plane projection is vertical and contains the line of greatest slope. They don't even fucking tell you, like. Find the value of theta that will give you a maximum range up the inclined plane. This is intense. I would panic. I think I did. I did really bad in this exam. Question 4. So this is the guaranteed question that comes up was always a pulley problem. And I studied the shit out of it always. And I did really badly. I fucked up the triple pulley problem. I only did this one right. I know this is the only one I did. Two particles of masses 6 and 7 kilograms are connected by a light inextendable string. The particles are released from rest. Find the tension in the string when the lift remains at rest and when the lift is rising up with a constant acceleration. Do you know what? We can solve this. We can solve this. Don't 6-7 me in the chat. We're all too old for that, lads. We're all too old for that now. A light inextensible string pulls over a smooth fixed pulley under a movable smooth pulley of mass 3 and over a second smooth fixed pulley. A particle of mass m1 is attached to one end of the string and a particle of mass 2 is attached to the other. The system is released from rest. Find the tension in the string in terms of m1, m2. Do we still want to go over this exam paper? Are we traumatized yet? So bear in mind, this is the stuff you were studying between the ages of 16 and 17. I think this is deadly. Really deadly. And you didn't need any physics prerequisite to do this and no higher level mathematics. I think this is mean. It's a Leaving Cert subject, so there's an Irish curriculum, Leaving Cert, and it's called Applied Mathematics. The physics exam is much easier. I can show you a physics exam. Yeah, absolutely. A smooth sphere A of mass 3m moving with a speed u collides directly with a smooth sphere B of mass 5m, which is at rest. The coefficient of restitution for the collision... What the hell? I don't even use those terms. Find the speed in terms of u and e, and find the value of e if the magnitude of the impulse imparted to each sphere as a result of the collision is 2. Oh my. This is like, I will be stuck in this. This will take me a huge amount of time to think about. Now, yes, I'm out of practice of these problems. If you give me a week to study for it, fine, I'll do well. But Jesus, I can't believe I sat this paper. Damn. Oh, I hate these problems. Oh. Vertical rod BA of length 4L has one end B fixed to the horizontal surface with the end A vertical above B. The ends of the light and extendable string. This is awful. Hi, Delara. Welcome in. Shumway. Welcome in, guys. We all are afraid. Let's all Yeah, let's all be careful. High praised. Is this the front page stream? No, I'm not on the front page. What are we so? I'm showing the applied maths exam paper that I sat when I was 17 years old, Phantom. I think the subject is excruciatingly unfair. At this point, how many marks had you attained? I didn't do well in this exam. This was an exam I threw. So what does throwing an exam mean? So in Ireland, we have a system. We have a point system, which means that for every Leaving Cert subject that you do, you can get 100 points. That's the maximum you can do. And to get into university, it is a popularity competition. And so the more points you get, the higher the probability you can get into the course of your desire. So maximum points you can get is 600. Technically it's 625, but for argument's sake, we're just going to say 600. Now, that means that it is inefficient to sit more than 7 exams. Because think about it, you'll only be graded on 6. I stupidly did 9 exams. This was a terrible idea, and I didn't do any easy exams. I didn't choose exams that were guaranteed to give me nice grades. Everything I chose was stupid. I wasn't smart tactfully. The applied exam paper was at the end. It was the last exam to sit, and I was between studying this and Russian. Those were my 2 choices. And I decided to gamble and study for Russian. And I'm so glad I did. So I got a C1, I think, in applied maths, while I got an A2 Russian. I think it was an A2. Still not an A1. So in the end, I had to gamble to take one subject that would give me better grading. I got really good points in the end. I think it was 520 points, which was really good. I got into any university that I wanted. I chose, like, there's a ranking system of what you chose, and I got my first choice. But I did not do well in this exam. I had to throw it. How's your Russian? I'm fluent, but I have terrible grammar. And I had to write a Russian essay and everything, so I did have to learn Russian. You might say that it was a guaranteed exam paper for me, but I wasn't very good at it. I had to learn writing. Oh, I don't want to look at this anymore. This is awful. Oh, God, that paper was so awful. I have great French grammar, but I can't speak with anyone. That's true. I suppose, sorry, not that I know that's true, but there is different types of language. So for example, I'm very fluent with Russian, but I have terrible grammar and bad vocabulary. Are the exams easier now or the same level? They're different. I don't understand them now, Phantom. They've changed the exam curriculum, and it's weird. I don't quite get it. I can't comment, basically. Statement on. Don't know how to comment on that. Someone asked to see what the physics exam paper looked like. So I will show you the exam paper that I sat when I was a student. Exam papers, 2013. Oh, you have to scroll really far back now. Oh, the further I have to scroll. Physics, here we go. So this was my exam paper that I sat when I was 17 years old. Now, physics is a lot easier than what you saw. This is my argument. Like, you saw those problems. Those were fucking hard physics problems. Now look at this in comparison. I think it's a joke. The difficulty level difference. Anyways, applied math is meant for those kids who are really, really amazing at mathematics. It's to cater for more mathematical oriented brains. You know what? We'll take it. We'll take it. Because there's a lot of subjects for more literature and art, for example. If you're good at writing essays, Obviously, the mandatory subject, English, all the languages as well, but there's also subjects like history, classical studies, geography even technically is considered more of an art because of the way the curriculum is laid out. So there's at least a lot of options. If you're more in the art and humanities, there are a lot of subjects to support you in that way. So, answer 3 questions from section A and 5 questions from section B. This exam was on Monday, 17th of June, bright and early, Monday morning. There we go. I would have loved to have met you when you were 17. No, you wouldn't. I was an awful person at 17. So section A was an experiment. So section A was always an experiment that was mandatory to study. So this was an equilibrium one. It was about plotting, get a straight line, Boyle's law, focal length of a concave mirror, current and potential. So basically you were given a bunch of data, you had to plot it, best line, explain the shape of your graph. It's just basically forcing people to study their experiments, which is really unfair as well, because some schools don't have the financial support to have all those experiments available. My university was very nice. The university I used to work at used to host an annual tour that if schools didn't have the experimental equipment, there was one day that the physics students all come to the university and they could all perform the experiment at least once. So if people didn't have the finances the school didn't have the finances to support the students, at least they had the opportunity to visit the school. Kind of nice. All right. Answer 5 questions from this section. Each question carries 56 marks. So these are a series of short questions. Answer any of the 8. What is the shortest stopping time for a car that is traveling 16 meters per second and has a maximum deceleration of 2.5? That's not bad. State the law of conservation of momentum? Not bad. Explain why heat does not travel through solids by means of convection. We can't kidnap the particle and get it to move? Not bad. Storage heaters are frequently used to heat buildings. State the principle that underlines the operation of an electrical storage heater. Huh? I actually don't think I know the answer to this. The principle that underlines the operation. Well, there's loads of different operations that are going on the electrical storage heater. No, it's not the second law. Is it just a supplying amount of heat? Like, lots of... It's the resistance one, right? That's all it is. What's an electrical storage heater, actually? It's not like a heat pump, right? This isn't a heat pump question by any chance. Okay. So it's an electrical storage heater is just that big wire that glows red. Kind of like and then there's a little fan to go shh and emit the heat out. Is that what an electrical storage heater is? Big wire, glows kind of red, really, really hot, and then a little fan in the back to whoosh the heat out a bit. Is that what I'm thinking of? Is that the same thing? That's an electrical radiator. Oh, then what's it? Okay, I need to look up what is electrical. Right, I don't even know what this is. Well, it doesn't matter if you have a PhD or not. You clearly I don't know enough to pass an exam. Oh, these guys. Oh. Why are they a storage? Oh. Okay. Yes. I had them in a lot of my houses. Why are they called storage heaters? Is it water that's in them? Oh, well. This is a trick question. This is a trick question. If a diamond has a refractive index, what is the speed of light? That's not bad. N is equal to C over V. Define a volt. Could just rearrange Ohm's law. A positively charged rod is brought near to a neutrally conducting sphere. How does a student charge a sphere negatively by induction? Again, not fair. This kind of stuff pisses me off because in rough schools or just neighborhoods that they don't have enough support, like their schools, and they don't have enough financial support, they won't have this equipment. The amount of schools I go to do my talks and support schools with, they don't have these apparatuses. This is like already an inherent thing. I didn't realize. Just thinking about how unfair that is. Like, already so many kids are at a disadvantage in these areas. If the school that they're attending is that's the chance that they get. And already they're set up for failure in a lot of these exams because they don't have access to this kind of equipment. Aren't most of them? I don't know. I don't know if most of them. What is meant by the statement, zinc has a threshold frequency, so that's got to do with the photoelectric effect. Give one benefit of switching from fossil fuels to nuclear power for the generate. Oh, that's a politically interesting question to have asked. Give an expression for the minimum frequency of a photon that can form an electron or a positron by pair production, or what event inside an LED causes the release of a photon? That's a nice, complicated question. Silver with the 55 stream streak, with Young and Harsh, by the way, in case I didn't mention it, just again. And Dark Shadow with the 10 stream streak. Let's go. Yeah, Delar, like, oh, I'm uploading a video soon about this. But I'll just upload it for you guys to have a look at some of these questions if you're interested. I am applying a bit for funding because I need some more electricity set up. And what I need is like, it's very simple electricity stuff. It's a Faraday cage, a few cones of different sizes. It's without a Van de Graaff generator, by the way. But it's stuff that you can connect to a power supply and a Van de Graaff generator, you know? So it's fun, interesting stuff. And I looked at the price and it was €3,500 for one set of setup. It's an exorbitant amount of money. Just $3,500 is more than the budget, annual budget for physics in total. And you need to spend, I think if you're lucky, you get about €500 a year. And that €500 needs to be spent on consumables, you know? Things that you need to replace every year. I don't know, I'm just getting really pissed off at the moment about the education system generally. I don't know. Oh, the marks. There we go, in brackets. These are marks. Yeah. Yeah, no, that's the idea of what I'm doing, laboratory. So hopefully this week I'll record it and upload it. My first video, my first release of my Patreon, which is designing and building affordable, scientific equipment with an Arduino, 3D printer, and a dream. So hopefully with schools that have like a budget of €500, one of those budgets, they can splurge on a 3D printer. And then the consumables would be like the Arduinos and so on and so forth. It is ambitious, it is, but I'm going to keep trying. I think, yeah. This is definitely a passion project. Oh, I just got really pissed off seeing those questions on if you didn't go to a nice school, not even a nice school, just a decent school that had funding. This is what they mean, like, of things that get slipped under the radar, you know, in terms of documentation and considerations, you know. What are they called? Not hidden agendas, hidden glass, is it glass ceilings? Where there are these kind of areas where on paper, no one is stopping you from graduating and getting high grades and doing well, you know, and they'll say that, oh, it's achievable. Everyone can achieve this. But yeah. So how are the disadvantaged students compensated during examinations? I mean, there has to be a way. They can technically study this. They don't have to do the demo. That's the thing. I don't know about you guys. Even as a lecturer, I do not, I tend to do demos. Even though I'm not a teacher, I'm a lecturer, I do demos in my lectures. Because my brain is very applied. So I don't tend to study a lot of theoretical physics, and I don't tend to learn off, nor do I understand things easily. I learn the best by doing. And because I do that, because of my learning abilities, I project that learning ability on my own students. I try to think of, you know what, I struggled this when I was a student, so I'm going to try and help my students out. Now, you could paint it and be like, that's not a great way of teaching. You know, you're not supposed to be projecting. Every single person is different, and I completely agree with that. But it's all about, in my opinion, when it comes to teaching, it's all about throwing a whole bunch of darts or a whole bunch of Velcro balls onto the wall and hope one of them sticks. The idea behind it is that you try to be relatable, you try to make it entertaining, try to reach as many students as possible with different themes, and just hope that one of those things stick with them. But being stubborn and doing it your one way and sticking to it is definitely not a way of doing this. Invisible boundaries is what they're called. Okay, there we go. Not doing the demo is like studying Shakespeare without seeing the play live. I studied Shakespeare without ever seeing the play. Although, we did watch the video. So, for me, my Shakespeare I studied was... Oh no, I studied two Shakespeare. I studied... I don't know why I thought this. The Nightmare Before Venice. Why did I think that? That was my junior cert. And for my leaving cert, it was Macbeth. But we watched the movie with Picard in it. We watched Macbeth with the actor for Picard. What's it? God damn it. The Nightmare Before Venice. Oh my. Questions off. All right. Well, as you can see, the Leaving Cert exam paper is physics exam paper is a lot different than the applied maths. But today we're focusing on applied maths, so that's what we're going to do today. I think we know a few lecturers like that, Delara. Yeah. Sorry, I got a little bit upset about it, to be honest, seeing that exam paper. Really upsetting to think about just how disadvantageous certain schools can be. Really disheartening. And it's just disheartening even in the education system. seeing people push against this and oh well. Happy Star Wars Day. Hi Steve, welcome in. Yeah, sorry for getting a bit upset about it. It's always a little disheartening to see. What we will do is we will probably make ourselves a beverage. I feel like having coffee, if that's okay. It is 2:30, it's quite late, but sometimes I have a light coffee like this at work. And today we are working. Today we are going to be doing, like I mentioned, pulley problems. So I need to pull out the whiteboard. And so we're going to solve a simple 2-pulley system problem. And hopefully after that, we have enough ability to look at 2 exam paper questions. I want to look at last year's applied maths exam paper because I saw it and I was like, that is so hard. But it's actually not. But sometimes you look at a pulley problem, you're like, Jesus Christ almighty, that is terrifying. But it's actually not that bad. We're not going to panic when we see the paper. We're going to hand out and we're going to solve it. So that's our goal today. I've never seen an office so clean. I know, I cleaned it. It's so clean, isn't it? I feel so proud. I know. I know that the concept of universal education is... That's not... No, I won't agree at all with that, Meg, no. It is capping people's ability before you even give them the chance for the assessment. I will say boldly that I would have been one of those people who was capped based on my social standing and my income. I should not have a PhD or master's or bachelor's, and I'm very, very lucky that there was some support in place for someone like me. So I wouldn't agree with that. You're just capping society and the advancement of mankind necessarily. Now you don't know where anything is. Stop it. I shoved everything. Like, it's just all in these. Look at this. It's just a mess. Oh, you can't see anything. The mic is covering everything. It's just... I just shoved everything in. It's all in presses now. All hidden. Hi, Tetsu. It looks clean on paper, but is it really? Okay, I'm going to go pee. I'm going to make myself a coffee. And when we come back, we're actually going to do some pulley problems. I'm going to teach you a very basic introduction to pulleys. If you want to quickly revise something, I recommend just quickly looking at Ohm's law. Not Ohm's law, sorry. Quickly looking at Newton's laws. The first law, second law, and third law. Just have a quick revision on those, and then we will cover those. Pulley problems are also known as free diagram problems, I think. Basically, a pulley and 2 blocks on either side. So that's what we're going to cover. I'll see you guys in a little bit. And that is why we tend to not use intensity to measure sound when we're conversing in everyday language. Decibels is a little bit easier to talk about. Happy sounding. What does the sun, Chernobyl, and a banana have in common? I know they don't walk into a bar. All of these things have radioactive properties, and I just want to talk a little bit about radioactive units. The reason I wanted to do this video is because there's so many, and I didn't realize just how many they are. The first one we're going to talk about is becquerel. You might know... I just jumped in there. I misread what Meg said. Oh! Wait, no. Never mind. Never mind, I take it back. I'm still confused. If a clarification is needed, please let me know, but I'm still confused. Never mind. See you in a little while. Another form of this unit is rad. You probably encountered this if you played Fallout. 1 rad is equal to 0.01 gray. That is how the rad is defined nowadays, but back in the day it was defined slightly differently. It was defined as 100 ergs absorbed per 1 gram of matter. And ergs was just 10 to the minus 7 joules. Another unit that was used in the past a lot is the unit Röntgen. If you watched the BBC Chernobyl TV show, you would recognize that this was the standard unit that they were using. This is expressed as the unit of exposure to radiation. From 1930s onwards, it was the standard unit used to discuss radiation and radioactivity. It is defined as the electric charge freed by the radiation in 1 cubic centimeter of air divided by the mass of the air. The problem with this unit was it was only talking about the radiation that actually traveled through air, and we know that sometimes that's not the case. We're talking about human bodies, that there's direct contact as well, and all of these things need to be taken into consideration. Around that time, we also had REM, a Röntgen equivalent man. This was basically associated with Röntgen, but it was talking about the effective dose. It was the value representation of how much it takes to start damaging the body. 1 rem is 0.01 sievert. And what is a sievert? The sievert is the SI unit where we represent the dangerous radiation. The sievert is an SI unit to represent the dangers of the ionization radiation. It is defined as the probability of getting cancer and genetic mutation due to the exposure of radiation. 1 sievert is equal to 100 rem. There's probably a lot more units out there, but this is just a quick summary, and if I left anything out, please let me know. In physics and English, we use the same words, but sometimes they have slightly different meaning. And here's 3 funny ones that you might have encountered, or maybe you haven't heard of. Number 1 is weight, and if you did any introduction to physics, they really drill you in the beginning that these are 2 different concepts. In English, we say weight, but what we mean is 1 kilogram of flour is its weight. However, what we actually mean is mass in physics. Weight would be if we multiplied it by gravity. It's the W is equal to mg relationship. Number 2 is the concept of theory. In English, we say, ooh, I have a theory that this might have happened, which might have little to no evidence to back up your theoretical claims. However, in physics, a theory is really well established. In fact, that's pretty much the final statement of a discovery or understanding in physics. For example, we have the theory of gravity, and I don't know about you, but personally I won't be jumping out the window anytime soon to try and disprove it. And finally, we have male and female parts, and this is not just in physics, this is interchangeable in a lot of technological terms. We have the female and male parts of cables, banana clips, all these kind of sorts of things. I hope I don't have to explain what the English of that is. If you have any other examples in mind, please share in the comments. Welcome to Physics of Video Games, and today we are doing physics of Baldur's Gate 3. Specifically, this incident that happened live on my Twitch stream.
Let's see what this does.
I'm not sure about that, but okay. I'm a bit worried about what that release brake lever would have done. Oh, that's... Before anyone judges me, I genuinely did not know what that lever would do. I am a type of player who presses anything and everything to see what happens, but I also don't scum save, so I continued the gameplay with the way it was. Let's do some circular motion physics and projectile motion on poor dead Barcus. First of all, I needed some confirmation that gravity was very similar to Earth as it is in this universe. We did find some official tweets by the creators of the D&D world, and we found that a falling object travels 177 meters in 6 seconds. We were able to determine that gravity was pretty much similar to Earth, 9.81 meters per second squared. We also need to determine the length of the windmill blades, and we're able to do some rough estimation calculations using screenshots and hoping that everything is perpendicular because alignment can be a bit of an issue. We were able to confirm as well with other models that this does seem to be close enough to the truth. We determined that the radius of our circular motion is 11.77 meters, which is the length of the windmill blade. Hi, by the way, hello, welcome back everyone. Happy Monday to all y'all coming back. Oh. So, before I go, I actually got a book. Evolution of Human History. So I thought, oh, this is really cool. I read some reviews. I thought it was a fantastic book. And I was like, oh, this would be a great book to read. Little did I know that this was one of these books. I thought it was like going to be, you know, like a textbook, like a normal reading book, but it's one, I don't know what these kind of books are called, like coffee table books? I'm not sure how to call them. You know, with loads of pictures and like loads of cool diagrams. Is there a name for this kind of book? I thought this would be like a light read, not light read, but you know, a light science-ish book to read, coffee table book. That's what I refer to it, yeah. Encyclopedia. No, no, not nonfiction. Like I thought it was going to be a normal, do you know, like a normal book you read in your hand with no pictures. Um, Hi Layla, by the way, welcome in. Mm, What would you use your recreational plutonium for? Great question. So, what could we use plutonium for? If I'm not wrong, we can use it in TNG. Um, no, not TNG. Um, thermonuclear um generator. No. What's the thing inside Voyager 1 and Voyager 2? The generator system. Is it called a TNG? Thermonuclear generator. Do you guys know what I'm on about? Or am I crazy? Radioisotope thermoelectric generator. RTG. Why did I think it was TNG? I thought it was thermonuclear. I was clearly thinking of Star Trek. I was just thinking of Star Trek the whole time. Let's be honest. Ay, ay, ay. Oh well. I mean, close enough. Close enough. I almost got there, you know? Yes. Anyway, I wouldn't mind having my own RTG. That sounds like a useful thing to have, you know? Where's my spray bottle? Spray my lab rats when they're bold. Check my cloth. Remind me in 2 minutes to go grab me my coffee. Clean all of this up. I would power so many systems in the house non-stop, Khaled. You could power like basically most electronic visual device systems in this house, sorry, for like 20, 25 years without needing electricity, like connected to the grid. That would be amazing. It would be an amazing, you wouldn't need a, so we all need one. I mean, no, only special people deserve them. If everybody has one, then I'm not that cool anymore. Want to be special. Ugh. Oh. Come on. Close enough. Close enough. So, I think I put some markers away. We were just joking about me shoving things away, shoving my problems away. Found some stuff. And you could use waste heat to warm your house. I don't have the impression they output a lot for the size. But if so what I said was for it to power all the basic electronic visualization of the, so it wouldn't be like to power light in the house or my PC or the fridge. It would be like any visual electronics. Now that I think about it, I don't have even that much. But if I'm planning on taking over the world, I'm going to need a lot of data analysis and a load of data collection sensors. So that's what I would use my RTG for. Back 2 seconds, my coffee's ready. Right, I'm back. Hello, hello, hello. Hello, World of Science. Welcome in. Hi, Nukinade. Wants to take over the world? That doesn't sound like recreational use of science. What do you mean? Taking over the world doesn't sound like recreational. What other possible purposes could you not or could have? Lads, you all need to get a better hobby. I'm just saying. Where he warms the cab of his rover with some decaying isotope. Have you ever done physics destruction? No! I should sit down and watch The Martian, although maybe reading it is better. So I read The Martian when I was a physics student. But yeah, I was thinking of more so doing Project Hail Mary. There was really nice physics in it. Hi, Slay. I'm definitely going to use Project Hail Mary next year. So the Artemis launch and Project Hail Mary is going to be part of my mechanics curriculum a lot. I don't know if I'll get to teach the students who are going to do common science, as in students who have the possibility of doing physics. I might be doing, because I have to teach physics to all first year science students. So I have no control over that really. So I might teach students who are like not interested in physics, but they're forced to do it. So the reality of it is I need to kind of adapt my education style to the group I'm teaching. Make it more fun, make it fun for everyone. Anyways, I have one textbook. Lo and behold, I didn't realize that there isn't actually textbooks. Well, I don't have access. Textbooks on pulley problems. If anyone has a textbook like with mechanics and pulley problems that they recommend, please let me know, because I couldn't find a single one. I've never really referenced them. But yeah, it would be great. So here we go. I have one simple pulley problem, just to kind of determine a few things. So let's take well, first of all, a lot of people are asking, what is a pulley problem? Well, a pulley is a system like this, right? Where you hang a string or a rope over it, and you have masses or weights or blocks, something like that, on the lines of hanging on either side. And usually in these problems, the string is not going to be stretchy, the masses are fixed, the rope is massless, just to make all of these things very nice and simple. I recommend Hibbler's Statics and Dynamics textbook. Okay. Are you in the Discord by any chance? Can you throw that into suggestions, if possible? Block A. Block B. Okay. And it's hanging from a wall. The squiggly line is the wall, and it's just, hanging there, just chilling. Frictionless, yeah, it's also frictionless, all the good stuff. I'm just referencing a textbook just for the introduction of the problem. Suspending on a string either side of a frictionless pulley. Part A, find the acceleration of 2 blocks. Question 1. So what pieces of information are we given? Well, we're given that this is 5 kilograms. And we're given that this is 12 kilograms. That's all the information I'm given. And the question is, what is the acceleration? Now, what's really interesting is the acceleration is going to be the same upwards as it is downwards. Now, looking at this, which one of those blocks is going to fall over the other one, chat? Which block, in which direction are the pulleys going to go? Is the block A that's going to go down, or is it block B that's going to go down, just by looking at this? B is going to go down. Exactly, Layla. It's 12 kilograms. It's heavier. So this guy is going to go down, while this guy is going to go up. Okay, that's going to be their net motion. So their acceleration here, the acceleration here, but the values are going to be the same. So if it's accelerating at 2 meters per second this way, squared, then it's accelerating in this direction 2 meters per second squared as well. Kind of, hopefully, you're like, oh, yeah, you know what? That makes sense. That makes sense. And we'll keep on going with that. Now, an important thing to note about tension. So tension is a term that we use when we talk about things, we talk about rope and mass hanging off it, or if you're pulling the rope. So let's take it from this perspective here. Let's isolate this story here. Let's look at the block and ask, hello block, how are you feeling today? Hi Luna, welcome in. Yeah, I like these markers. They're really nice. I really like these big markers. I'm going to invest in more of these guys. I really like them. I'm not fat shaming anyone. The reason why is because you can draw really thick like this. That. Or very skinny like this. So you can adjust the thickness of the marker on the board, which is great because when I make social media posts, I feel like sometimes the marker is really, really hard to see. So this really helps out, I believe. Are the markers huge or is tofu just tiny? Listen here. Listen here. Oh, sorry. My Discord is !Discord. Apologies. You're free and welcome to come and hang out. If anyone else wants to join our Discord, they can. We have loads of science channels and gaming channels. So whatever you're into or up to, you're more than welcome to chill with us. We're not usually too mean. Usually. Mostly. Coffee. Okay. So tension is something that is felt by the string, is from the perspective, and it's what is being tugged at or pulled at. So let's look at this story here, right? Let's look at the block A. We know that the block A has mass, it has weight, and it goes down, right? So the force that it experiences is its weight. Force is equal to mg. So the weight that it experiences is mg, or otherwise 5g, because I've subbed in for mass there. The tension, however, is what's tugging at the string. We know that there's something else going on in our system, definitely.
And they call
So the
it
tension
a
it feels in this direction.
mine.
Mine. Matey, thank you so much for gifting Prasha gifts. You're very kind. Thank you. You're very, very kind. I needed the link. I accidentally... Oh, no worries, no worries. I don't know what the answer is. I'll be honest, I don't. Oh, actually, I do know the answer. The answer for A is meant to be 4 meters per second squared. So what is 70 divided by 17 about 4? I'm Larkin, welcome in. Hello, Larker and Tofu. Now, if we look at this story here, it also has a mass, mg. Its weight, its force is going down, mg. In this case, it's 12 times g, force down. And in this direction, it still has the same tension. And you might be saying, well, Tofu, that's not right. How could I have the same tension? Well, think about it. If this is the same string all the way through, if I am tugging at a string this way and you're tugging at the string that way, at any given point on the string, the tension that's in the string is going to be the same. How could it possibly have a different tension here than over there? That just doesn't make sense. That's just defying the laws of physics. Remember I told you to revise your 3 laws? Hi, Rex. Welcome in. How are you doing? Welcome in. Welcome in. Now, another thing is that we isolated all the mini stuff that's happening. We've isolated what's going on with the mass of the block. It has weight and it has tension, but it's also moving. There is a net force story, and the net force story is in this direction. You already kind of drew it here, and this is F. Whatever bullshit we're doing to this poor block, in the net goal, this mass is moving up. Same thing can be said here. Doesn't matter what bullshit is happening to this guy. I don't know why I keep saying bullshit, but we could do anything we want to this. In the end, there is a net story of a force going downward. Now, the beautiful thing about this, or the kind of the solving mathematical aspect about this, is that we have two sets of very nice equations of all the forces. We grab a story and we're going to equate all the forces. What we're basically going to say is all the forces up must equal all the forces down. That is the basics of all of these free diagram pulley problems. Even when you do ones at an angle or an inclined plane, your whole goal of solving these things is to get them all in line. They might be going opposites, which is great, because then you can equate each of them on either side of the equation, and you're getting them all in forces, probably in their other terms like mass times gravity or frictional force or all those other terms. And you're going to equate them in the end. That is our goal. Saying bullshit is a learning aid. I hope so. Yes, Sunday, we're doing pulley problems today. I definitely swear sometimes when I teach, not so much so, but when I tell stories, when I talk about drama between some researchers, not like actual real drama, I mean like historical drama between Newton and Hooke, or Dirac, Pauli, Einstein, Schrodinger stories. Sometimes to kind of play it up, I do swear in their voices. Hi, John. Welcome in, Jonathan. Hello, DJ Zinway. Welcome in, everyone. So we have two stories, basically. We have what this block is feeling and all the story in it. We have what this block is feeling, story in it. That's exactly what we're about to do. We're actually going to solve those things. So let's look at the first story. Story A. Force A, the net story, is equal to tension. It's in the same direction. I did that wrong. Yes, I did do that wrong. Is equal to the opposite. Would it be easier to do it this way? Yeah. All the forces up equal all the forces down. Force A is in this direction, plus T in that direction is equal to all the forces down, mg, 5g. Have to think about it. So all the forces up equal all the forces down. Fa is a force up way, is plus tension, it's another force going up, is equal to all the forces down, 5g. What Newton's law am I thinking of here when I'm equating all these forces up and down? Actually, I thought I was going to hint towards the third law, but honestly, it's not really. It's ever so slightly, but not really about it. Really, what we're doing is Newton's second law. It's mostly, and all of it is just second law. I was thinking that there's some third law here because all the forces equate to cancel out, but that's not really a proper term here. I'm just going to lurk. No worries. I really appreciate the lurk. It really helps with the VOD hours. And like I said, I'm trying to get monetized, so it really helps right now. Going back to school as a physics major. Let's go. I wish you the best of luck with that. No, mostly it's the second law. F is equal to ma. This is ma. This is ma. And it's all the forces equating each other. That's why I think it's the second law mostly. Honestly, it's a combination of everything. If you really think about it, it's a combination of everything. Okay. Now, this is the force, tension. This is a force, that's force is equal to mg. But Fa, we need something here. Well, that's just mass. Remember, force is equal to ma. That's just mass times acceleration, a, plus t is equal to 5g. There we go. Now, do we have the mass? We do. The mass of the object is 5. So it's 5a is plus t is equal to 5g. So we have an equation for the first one. Oh, I did something wrong. I knew I did something wrong. I didn't believe me. I doubted myself in the beginning. Hi, Avondriel. I knew. Okay, look. It happens exactly. We're all going to brush back. So remember when I said all the forces is equal to all the forces down? That is true when we're dealing with, if I was just dealing with tension and this guy, that would have been true. But really, there's a different problem, what we say. We have the total story, FA. FA is the net story. Basically, if we don't look at this guy at all, I suggest drawing free body. Isn't that kind of what I did? Okay, if you want me to draw it a bit better, I'll do it again. So if we look at the block 5 here, it has a tension acting this way. It has its mass, mg, acting this way, 5 kilograms. And it's moving in this direction, A. So the net force, Fa, is in this direction upwards. That's the free body diagram for it. But in reality, like this is exactly the same thing that I drew here. The bane of dynamics, is it? So, Fa is going up, and it's going to equal to all the so let's look at all the forces. So the forces that are acting upwards in the same direction as Fa is T, the tension. And what are all the forces going down? We're going to minus them. T is positive because I took Fa to be positive. If A is going up and I took Fa to be positive, it means that the tension has to be positive on the other side as well. But the mass, the weight of the diagram must be heavier. It is acting downwards due to gravity, and it's in this direction, minus 5. So we almost had everything correct, just kind of a small pedantic mistake there. Force of A is equal to m times acceleration. The mass is 5, acceleration is A equal to t minus 5. I want to make sure that I have that right. Oh, all right, my phone is vibrating. Emails. May the 4th be with you, and so be with you. Welcome in, mate. So that's the first equation that we have. The second equation that we can get is from this story. So let's look at this guy here only. Okay? Let's look very carefully. I'm going to take now, just to spice things up, I'm going to take the positive sign to be going downwards, just to be spicy. So that's going to be FB is equal to all the forces acting downwards, which is 12G, and then minus all the forces upwards, it's just T. Remember, FA is the total story. And then we break down what's happening in the total story. It's the tension and the weight. And then FB is the total story of B. We break it down by its weight and the tension. That's what we're basically extracting from these equations. FA and FB are the total stories. Okay? So those are our equations. One quick thing. FB is equal to 12 times A. Okay, so we have two sets of really interesting equations. Sorry, I keep blocking the board. We have equation 1. We have equation 2. How many unknowns do we have, chat? One as G, exactly, G is known. So we've just, no, there's two unknowns, there's two. A is an unknown. We do know G, right? But T is unknown as well. So there's two terms we don't know. We also don't know tension. Don't forget your tension, the tension in the room. So let's write out those equations here on this board, and we're going to solve this together. It's basically, you can solve this in different ways. You can do this by simultaneous equations. You can do it by just rearranging the equations, substituting the other. Whatever you prefer, you can do. Can I do simultaneous equations? It's been a long time since I did those. Let's see how my memory fades or works. Hi, Mord. Welcome in. So the number I'm looking for is A. So let's cancel T. We're canceling T. He did something bad on the social medias, so it's getting cancelled. Well, they. Now, how do I do simultaneous equations? That's a good question. No, we're going to take G to be 9.81, but we're going to avoid substituting as for as long as possible. We're going to avoid substitution for the longest as possible. By the way, Blade, 12 minutes ago, if you're still here in the chat, you had a 350 stream streak. I didn't salute it. My days, that is incredible. Matrices is definitely overkill for now. It'll only I do some matrices sometimes in DC analysis, but not so much in these, no. In fact, in the Irish mathematical curriculum, matrices were removed like almost 10 years ago. So yeah. So if I remember how to do simultaneous equations, it's actually already set and ready to go. Those two T's are cancelling because we have positive T here, minus T here, so it's actually ready to go. So what are we left over? We're left over with 5A plus 12A, which is equal to 17A. We're left with 12G minus 5G, which is 7G. So rearranging that equation, we get A is equal to 7G divided by 17. Oh, I could be completely wrong. I could have completely forgotten how to do simultaneous equations. Correct me on that. I have a calculator here. Let's find out. 7 multiplied by 9.81 divided by 17. We get an answer of almost 4. Yeah, okay. 4. And what's the unit for acceleration? For what? Meters. There we go, per second squared. It's the rate of velocity change. So rate means per unit time. Velocity is meters per second. Another unit time, meters per second, meter per sec squared. Exactly. So now that we solved A, we could also solve for T immediately, and you can grab any equation you want. Let's grab this one. That's 5A plus 5G is equal to T. I've just rearranged the equation a little bit. 5 times 4 multiplied by 5.98. Put that into your calculator. 5 times 4, which is 20, plus roughly 50. No way. Nice. So it turns out that the tension is 69 watts. What's the unit for tension, chat? Hi, Carrie. Welcome in, welcome in. Newton, exactly. Bear in mind that what we're doing ultimately mathematically in all of these things is that these are all forces. We're saying the total story force is equal to the force that's pulling it up minus the force that is pulling down. So remember when you did friction a long time ago? You had a block and you were pulling it this way with a net force. It was moving with a net force, but really you were applying way more newtons, let's say 30 newtons. And then there was the frictional force, and you had to subtract the difference between them to calculate what the net force was. That's exactly the same thing what we're doing. If you think about it, we've just flipped everything upside down. We don't have friction now. We have tension and we have weight. But that's exactly what pulley problems are ultimately. It's friction, but in air and flipping things upside by 90 degrees, pretty much. So if you're used to friction problems, maybe slowly you'll get the hang of these guys as well. Coffee, good coffee. Oh, Seven Blade. No, thank you so much for that huge and amazing stream streak. Thank you so much for the long support of this channel. Okay, so that was the only problem I was referencing. So now, after I've done all of that, I think an interesting thing to do would be to solve past exam paper questions of the Irish Leaving Cert. So my goal is to solve last year's one because that one was really, really hard. But before we get there, let's just look at maybe the year before that, 2024. Programming overlay, and I'll show you the exam paper first. Let me look at this. A student sets up okay, let's see if this is doable. Do we have enough knowledge to solve this, chat, is the question. Let's look at this question. Do we have enough brain cells for this today? A student sets up a pulley arrangement as shown in the diagram. So this is a triple pulley problem. Well, double? Is this a triple or a double? A light and extendable string passes over two smooth fixed pulleys and underneath a movable mass of 6.3 kilograms. The weight of the first mass is 24.5 newtons, is attached to one end, and the other one is 44.1. The system is released from rest. Show in separate diagrams the forces acting on the pulley. Calculate the tension in the string. And that's it. So really our goal is calculate the tension in the string. What is the tension in the string with the information that they've provided in this exam question? That is the goal of the problem today. Or one of the problems today. Was tension on one side, was tension the one that could not be negative? No, they can be negative. It's just about direction. You can't, oh, I see what you're, is that what you mean? In this case, you can take tension to be negative or positive. It doesn't matter. You just say, I've decided that going up is positive. So all the forces that go up have to be positive. Or I could have said all the forces going down have to be positive, which means that because tension acts upwards in all these pulley problems, then the tension would have to be negative in my body diagram. Does that make sense? I don't know if that's the actual question you were asking, or am I getting confused? It doesn't sound so unusual that I got confused. Oof. Yeah, like if I had a helium ball. It's just a directional thing. If the tension begins to act one way over the other. It's that's really most things in physics are actually like that. If it has a negative sign, it's going the opposite way. Is the general idea. Hi Slay, welcome in. Thank you so much for the raid. What were you doing today? Welcome in, raiders. We're just doing some pulley problems. I'm showing the exam paper for the Irish Leaving Cert Applied exam from 2024, and we're going to solve that at the moment. Before we try and solve a really complicated exam question from last year. So we're going to solve this one first. I'm so dumb. Doesn't the heavy one go down and the other one go up? Yes. Yes, Carl, you're right. This goes down. And this goes up. Let me show you something. Let me show you something. When I look at this diagram, I could do a whole lot of things here. I'm going to show you something, okay? There's two ways I can write this equation. Sorry. I could say FA going up is equal to the tension going up minus the weight going down, mg. I could also say, you know what? Things going up are going to be negative. So minus FA is equal, T is going up, and I said that this is the minus direction, so that's minus T, but this is going down, so it must be positive plus mg. Both equations are true. And it's just up to me and what I think is best to place. Exactly, Chris. When you rearrange the equation, it would net be 0. McLovin, thank you so much for your prime. Really, really appreciate it. Thank you. Hi, I'm from the raid. Welcome in, John. Welcome in. What were you guys doing in the, today? Then it crashes and the pulley jams up and everything. This is something to explore for a physics project and a 3D printing project, by the way, is can we design a physical pulley? I've never seen a real pulley problem, like an actual demo of a real pulley problem before. So it would be cool to see that. He was outside playing. Oh, cool. Playing basketball. Streaming playing basketball is really, really cool. That seems like a great educational stream. But it doesn't matter, Call. Why? Okay. When you're doing a projectile motion problem and I throw a pen up, okay? Why do you take gravity to be minus or why do you take gravity to be plus? When I say I'm moving at minus 5 meters per second in this direction, why did I say minus? Why did I choose that this direction is negative? It's just one direction is positive, the other direction is going to be negative. It's arbitrary, exactly. It doesn't matter which direction you choose to be positive or negative. It's up to you. It's a very personal thing for yourself. We used real pulleys for this in middle school. Like you had a real demo in middle school. That's a really nice middle school you had, Arwale. I've never, I wouldn't say I've come from a good school or anything, but I went through universities and no university I've attended had access to a real demo pulley. It has to be consistent. Exactly, Fanfrost. The only thing you have to keep track of, it has to be consistent. You can't halfway through the equation decide, you know what? Down is going to be up now. Or down is going to be negative because I changed my mind. If you chose down to be minus, you have to stick. All the forces then have to be minus. It is up to you, but whatever choice you choose, you got to stick to it. Is it called sign convention? I don't know if that's true. Sign convention means that we assign a sign to something just by practice or sheer popularity. But I don't think that that's the proper term here. I could be wrong. Someone can jump in and be a bit more pedantic there to me and say, Sophie, you're wrong. But I'm not sure about that. If someone said sign convention to me, that would mean that in practice, we chose A to be minus because everyone else chose that. But yeah. That is up to them. Let me draw up the next problem. This is 2024 Leaving Cert exam paper. It's a double pulley problem. Fun. Chat, you better be having fun. We're having fun. If anyone says otherwise, you have no choice in the matter. Amaze, amaze, amaze. Oh, Meche, are you here? Meche, have you seen Project Hail Mary by any chance? Because I would love if we could have an emote from Project Hail Mary, honestly. I love that movie. We could even have simply a thumbs down emote. A thumbs down emote would be awesome. A rocky thumbs down. With my bump. A rocky emote, exactly. We'll have to look at seeing if we can maybe design him. I wanted to make that exact emote, but I wasn't sure about copyrights. Oh. Well, I mean, we have a face hugger hugging a tofu. I feel like a rocky thumbs up would be okay. If we had fully rocky, that might be questionable. But I think a rocky thumbs up, oh sorry, thumbs down is very, that's, surely no one can copyright a thumbs down. Watch me eat my words. We can just make tofu with 5 legs. Oh my god, that would be so funny. Yeah, no, I really like the movie. I know a lot of like hardcore science people might be a bit negative about the movie, and everyone complained that it was a cringy movie and cheesy, but you know what? Honestly, we need a bit of cheese and cringe in our lives. It was just a bit of fun. It was a feel-good movie and some awesome science in it still. Yeah, I thought it was good. Cheesy. So I like cheesy. I love cheesy dialogue. Like some of my favorite TV shows of all time are like things like Buffy the Vampire Slayer. If you watch that TV show, it's the cheesiest cheese on a 7-cheese pizza. Like it's it's so fucking. Anyways, it was wholesome. Exactly, it was really wholesome. Yeah. All right, so I'm just gonna draw the problem up and analyze it together. I might try and fix the lighting a bit actually, because there is a big glare. But if I use them like this, I could maybe turn off this light. See if it's any good. Oh, I'm a bit dark. Maybe we keep this light on, but we turn off this one. Okay, that's not too bad. We only have one glaring light, but you know what? Oh, and we more. Yes. Hey. Not bad. Using your laws of reflection and refraction, chat. That's what we need to do. Hi, Srujan. Welcome in. Welcome in. Happy Monday. Yeah, apparently the science explanations are very good in the book. I hope to read it. I gave it to, I think, Herder. Herder won one of the prizes, which was a collection of blind sci-fi books. So, yeah. Hi, Conrad. Welcome in. Or go read the book. My pimple is really sore. I keep touching it. Sorry, I need to stop touching. It's so painful. Isn't that a sign of still being young? Getting pimples to this day.
May the 4th be with you. And also with you.
So this guy is 6.3 kilograms. This guy has weight 1 and weight 2. Weight 1 is equal to 24.5 newtons. And weight 2 is equal to 44.1. The board is still a bit wet. Okay. And then the question asked, I think it was to calculate the tension. Am I right in thinking that? Calculate the tension in the string. What is the tension equal to? So now that I've written the problem on the board, do I have the answer for that year? I do have the answer. Okay, so it's just good to kind of make sure that we're in the right trajectory. Actually, no, it's a sign of hormonal imbalance. Usually too much testosterone. Oh, you're saying I have too much testosterone. All right, all right. All right, all right. Massive muscles, exactly. I need a lot of that where we're going. Okay, so let's, tiny hench tofu. Let's solve this problem. Let's do some free body diagrams. Now, this is going to be interesting. We have 2 sets of ropes, don't we? Well, no, we still have the same rope. That's probably wrong to say. But how should I say this? Our acceleration is going to be different now. This is going to be problematic. First of all, this wouldn't, this is 24.5 newtons. I'm going to assume, we could be wrong. Both blocks could end up going up. We don't know. We don't know what's going to happen. But I'm going to guess that this guy is going to go up with the acceleration of A. And this guy is going to go down with the acceleration of B. Obviously, this guy has to go down. I'm just doing rough maths. 6 by 10, 60 newtons. It's going to be heavier than those two. I'm doing some rough maths thinking that it's going to go down. Or this guy could go up. We'll see. Yeah, I've chosen it to go in those direction. Are those 2 different? No, that's not forces. Those are accelerations. Accelerations that I've drawn on the board. But what about this guy? Let's say it goes down. It's okay. It's okay if we're wrong, by the way. It's okay if we're wrong and we get our ups and downs mixed up. The good news is if we keep track of those minuses and pluses I mentioned earlier, we're going to keep track of all of these things. Now, here's the question. What's going to be the acceleration of this guy going down, let's say, in this example? You could say it's going to go down a new acceleration, C, but let's be smart. Let's use our physics brains a little bit. What combination of A and B will it be? Say it goes up. Boy. Correct. Average of the 2. Fan Frost, you can take a round of applause, a little bow there. Average. There's going to be A plus B over 2. If the stretched things are going to be over it like that, it's going to be a combination of those both. Now, let's look at this guy. So the green is just me identifying acceleration, but let's look at all the forces. The forces acting on this guy is the tension here and the weight down, 24.5 newtons. In this one, it's going to be the tension acting up, and it's going to be 44.1 acting down. Okay, those are all the forces. In this story, there is the force going down, which is mg, 6.3 times g, What about tension? Are there any forces going up? There must be, right? Tension 1 and this guy experiences 2 tensions up. There's going to be 2 T's involved. Very unusual in this case. Find the marker I was using. Oh, there it is. I think it's just generally an assumption, yes. Let me see if I have, yeah. So T for 2 then? T for 2. So let's look at this guy here, FA. The force that a block A is experiencing, we're going to call it A, is equal to, so we're going to take up to be positive in this case. It's going to be equal to the tension minus 24.5. That's the weight. FA is equal to the mass times the acceleration is equal to T minus 4.5 newtons. We don't know the mass of weight 1. But there's 2 strings involved. Can't be just 1 T. There's a string here pulling it at tension 1 that has 1 tension, and there's another tension here at T. It has to be 2 strings involved in this case. Do we know what the mass of this block is, chat? We're going to go on a side quest. Weight is equal to mass times gravity. 24.5 newtons divided by gravity, in this case it's 9.8, is equal to the mass. So if you put that into your calculators, 24.5 divided by 9.8, we get an answer of 2.5. We actually know what the mass, oh sorry, the lighting is terrible. We actually know what the mass is of this block. This guy weighs 2.5 kilograms. Let's quickly do this for weight 2 as well. That is 44.1 newtons divided by 9.8. Get an answer. 44.1 divided by 9.8. 4.5 kilograms. This guy weighs 4. So looking at this equation, M becomes 2.5. We have an equation. 2.5a is equal to T minus 24.5 newtons. Not bad, not bad at all. This could be 2.5 multiplied by G, but we're just going to keep it. It gave us in newtons, we might as well. So let's look at this free body diagram as well. Let's get an equation for it. So I'm going to say F net is up again, FB. The tension is upwards as well, T, minus the weight is equal to 44.1 newtons. FB is equal to the mass times acceleration, 4.5B is equal to T minus 44.1. Hi, Anna, how are you? Are you at work or working from home today? Welcome in, welcome in. Hopefully you'll be streaming tonight. Let me double check here really quick on the exam paper. I just want to make sure that I'm getting the right answers. It said that this was 2.5a is equal to, oh, got this wrong. Got all the signs wrong. Shit, I got this wrong, chat, according to the exam paper. Oh, it's okay. I didn't get it wrong, I think. So what's going to happen? Yeah, I think it's going to be fine. It's going to be fine. So they took one of them to be positive or negative, and we're going to get the right answer in the end. We're going to be okay. Exam papers are wrong. It's fine. No. I think it's going to be okay. So in the exam paper, it says 2.5a is equal to 24.5 minus t. That's just because they took the force net to be downwards. It doesn't matter. In the end, we're just going to get a minus sign. And they should, if they're marking this correctly, correct it correctly. But it's fine. It doesn't matter. I'm getting really warm teaching. I'm going to take off my jumper, but I'm scared that my top will pull up and I'll break TOS. So 2 seconds. Off today, but just got home from a nail appointment. Nice. Are you going to be streaming tonight, I hope? Let me just take this off stream. Oh, quite warm. It's the third weight. It's going to move. Yeah. That's why it has acceleration. That's why we've assigned the third pulley some acceleration. So we'll say this is equation 1 and equation 2. We can get a few other equations as well. That is the plan. Yes. What's on the menu tonight for us? The third equation then. Oh, I actually don't know. Yeah, surely we need to. What have I been taking? I've been taking the force up being positive. So in this case, if I'm keeping track of everything I'm doing, but you know what? I'm going to change my story. I'm going to decide, you know what? Force downwards is now going to be positive. It's okay to do that in isolation. Cheeky 135. Let's go, bloatware. C is equal to, so I've taken downwards to be positive. So 6.3g, going to act downwards. It's in the same direction. Minus, what's going up is the two t's. Two of them are going up. Minus, in fact, I think this fits the exam paper. If I'm not mistaken. No, I got it wrong again. I'm doing the exact opposite way of everything that it does. You know what? It's fine. It's fine. We'll stick with it. The exam paper doesn't know the right answer. That's what I'm saying. Hi, Spooky. Welcome in. So this is the mass, 6.3 times the acceleration. Remember, it's the average of those two accelerations. So that's A plus B over 2 is equal to 6.3g minus. There's our third equation. Now, chat, how many unknowns do we have? No, because the tension is the same, Fran. It has to be the same. It's the same string. How could you possibly have more tension, like 1 Newton on one and 3 Newton on the other? It's the exact same string. The tensions have to be the same. So it's 2 T's. We don't know the air resistance. 3. T, that's right. A and B. There's 3 unknowns. But the good news is that we have 3 equations. So if we're solving for T, let's do exactly just that. The music that's playing sounds like frost punk. And I'm kind of like, I had cheery music. I was playing City Skylines and suddenly my playlist changed to frost punk. That was very on theme of the... No. It's all good. It's the same string. Yeah, exactly. So let's find T. Well, we have 3 equations. We can do simultaneous equations on all of them if we want. Will that be fun? We're looking for T. If you have 3 equations and simultaneous equations, can you cancel 2 things simultaneously? Or do you do... Guys, I'm so sorry. It's been years since I did simultaneous equations. And remind me how to do it with 3? Or we can just do this subbing in. I want to finish Fallout 3 DLCs. Okay, fair enough. Lana says I'd enjoy Fallout 3. 3 unknowns, 3 unknowns. 3 equations and 3 unknowns. So it's very doable, but which way to do it? Okay, how about we solve for the term A here, and we sub it in this equation, and we solve for the B term here, and we sub it into this equation, and then we solve for T. You could do this a bazillion different ways. It's up to you. This is where your artistic integrity gets questioned. But you know what? I think that's not a bad way. Let's do the first one. 2.5a is equal to T minus 24.5. Go. I'm just thinking about what I did. Yeah, okay. So let's rearrange the equation. A is equal to T over 2.5, which is 5t over 2 minus 24.5 divided by 25. 24.5 divided by 2.5. 9.8. Exactly G. Of course it is. I forgot about that. So that's A is equal to 5t, or 2.5t, we'll say. We have a term for A. Let's look at the second equation, B. B is 4.5 is equal to T minus 44.1. So we're going to put 45 across. We're going to divide across. That becomes B is equal to 40. Oh, all right. That's meant to be T divided by 2.5, by the way. There. That's going to be T divided by 4.5 minus D. There's a lot of interesting topics that you could speak about. What's your favorite part about physics? Like a favorite subject would be thermodynamics, but I don't know about favorite part. I was just going to say, the image behind you looks a bit naughty at quick glance, or I'm very sick. The image behind me? Triangular three-sided whiteboard when? So we have equation 2. And using equation 1 and equation 2, we're going to sub in for both of them. So this is going to be very messy. 6.3 in brackets. Oh my God, why am I doing that? Very messy. E divided by 2.15. Why am I doing that? It is Ryuk from Death Note, yes. Let's do it in decimals, just in case. 0.4t minus g plus 0.2t minus g all divided by 2 equal to 6.3g minus 2t. Let's do some maths here. That's 6.3, 0.6t minus 2g divided by 2. So that becomes 0.3 minus g. .3 multiplied by 0.3 becomes 1.89t minus 6.3 is equal to 6.3g minus 2t. 12 minus 12.6g is equal to minus 4.89t. The minuses cancel. Bring that across. T is equal to 12.6 multiplied by 9.8 divided by 4.89, and t is equal to 25. Hi, Garrett Hall, welcome in. Hello, Jimmy, welcome in, welcome in. I got the answer wrong. The answer is 31 newtons. Wait, how is that 4? That's meant to be 3. 12.6 multiplied by 9.8. Divided by 3.89. Yes! We got 31.7 newtons. Woohoo! Let's go! Oh, feels good, man. Feels good. So even though I did it completely different to the exam paper, we still got the right answer. I don't know why. I thought minus 2 minus 1.89 was equal to 4.89. It was a very silly mistake. But we got the answer in the end. Not bad. So it's really interesting to point this out, though. I did not get the same answer as the exam paper. I didn't do the exact same way as the exam paper. It ended up like what we did ended up doing is like what I took to be positive direction and what was negative direction was the opposite. But it shows that staying consistent and not making stupid mistakes still gets you this exact same answer. How are you getting on, Jimmy? It's a day off for you guys as well in the UK, isn't it? There we go. We solved the 2024 exam paper, but the goal is to solve the 2025 one, which I thought was particularly interestingly challenging. And that one is going to be very long. So you better get your butt cheeks ready for question 2025. I'm just saying. No, I'm working today using a day off in June instead. Oh, that's nice. Do you get like double day though? Because of like, if you don't take this day off, do you get like 2 days or something return? No, it's an assumption, sure, Fran Frost, but it has to be true. If you've 2 tensions and you've 2 of the strings going through, then the acceleration of one and the acceleration of the other, if it's connected by 2 strings, it has to be the average of the 2. Oh, my company just lets us move the bank holiday. Okay, fair enough. I remember study this in college. Yeah, well, it can be nice and easy for sure. There are a lot of trick questions out there for to challenge people, but it is really, really nice. Rogue Jelly, thank you so much for gifting a sub. A mine. You call that a mine? I got so worked up with the question I had to take off my hoodie. Do you guys know each other? Sujan Rogue, hi. Thank you so much, Rogue, for gifting a gift sub. You're very kind. So what we're going to do, in case anyone was wondering, we're going to do one more pulley problem, and it was a particularly challenging challenging Pulley problem from last year. So I'm going to take a quick break. My knees are sore from standing. I don't know why my knees get sore on stream, because I lecture for hours on end in a hall, and it's not this bad, but particularly on stream, quite painful. It was me or Herder. Yeah, Herder's everywhere as well. You have to say Herder's name 3 times, and he'll pop up. Do you walk? Yes, I do. I definitely walk around the room when I lecture. It's probably standing still on stream. I don't sit down, nor do I stay in one place when I lecture. Move around all the time. Need to replace the carpet padding. Need to get these knees replaced. My knee joints need some replacing already. Good old 30s. The good old 30s. Yes, university. Hi, Spooky. Welcome in. We have another Spooky in the chat. Oh, no. An elder streamer lady. That is true. That is true. We have a ghost hype train incoming. Choo choo! All aboard the ghost train. I wonder if I wonder if there is a movie already called Ghost Train. Spook Train. You start heating up when you're studying. Who used to say that the brain activity was very exothermic and it's very calorific? What was it? I think it was actually Death Note. It was L who said that the reason why he eats so many sweet things and burns calories is because he uses his brains so much. Dinar, thank you so much for the celebration. Well, I hope you enjoyed a weekday stream. It's not over yet. Not over yet, but I hope you enjoyed the weekday stream. And it's nice to do a bit of physics occasion. I need to remember to do one. Ghost Train. Oh, is that a Korean movie? I'm just noticing by the names.
A mine.
A YouTuber with the lowest number of views.
A mine. And they call it a mine. A mine.
Carla! Oh my god. Thank you so much for gifting 10 community gift subs and breaking the sound alert.
71 years is far too short a time to live among such excellent and
Breaking this level 4 hype train.
I don't know half of you half as well as I should like, and I like less than half of you half as well as you deserve.
Choo choo! All aboard the scam train!
Choo choo!
Motherfucking choo-choo!
Thank you so much for giving all those gift subs. I hope anyone and everyone who got them enjoys the subs, all created by our wonderful and talented Medjay. He created all the artwork on the stream, and I don't know how to say it other than I couldn't be more grateful. You've given a total of 60 subs on this channel. Huge, generous support there. Thank you. Thank you so much. I was going to go on my break, but the rule is I can never leave when we're in the middle of a hype train. That's the rule of the stream. That's the rule of the stream. I may not leave. I cannot leave if we're in the middle of a hype train. I must continue. I must suffer. Well, while we're having the hype train, I guess I'll clean the board. My poor knees. All blame Carlo the Curious for this. Streamer can't even take a break for her poor old knees because she's been giving gifts subs. Oh no, poor streamer getting money. So mean. So mean. Hi, Lostage. 3.5 minutes of awkward silence it is. Imagine. That would be a funny hype train thing. That every time there's a hype train, I have to be silent. Like, stare at the camera non-stop. Very weird. That could be a fun gimmick. April 1st, perhaps? Wait, so if we keep the train going long enough, Tofu will never be able to pee? I guess so. I guess, yeah. That happened before. Not the peeing part. I did a 12-hour stream, I think, or a 15-hour stream, and I really wanted to go. But the rule is I can never leave. And so I think my community kept a hype train going for an extra half an hour, so I was so exhausted. Hi, $50 Tech. I'm so happy you found the stream. How'd you find this? Welcome in, welcome in. Hostage. Exactly. I've been kept hostage. Oh, nice. NASA will be along to install an astronaut toilet at some point. Enable never-ending high stream. They're very good at that. They are very good at that for sure. We've cleaned the board, and my goal is now to solve the last exam paper. This is last year's exam paper. And this is the YouTube video I want to create. But when I tried to solve it myself on my notepad quickly, I got the wrong answer. So I'm going to try and solve it with you guys and see if we get the right answer this time. Zero G toilets is the sucking stuff. I remember if you look at Space Odyssey, the movie, while he's traveling in the spaceship in Zero G, there's actually like a little rule thing about how to use the toilet in Zero G. I don't know if anyone spotted that. I highly recommend looking it up. It's quite funny. If you don't solve it yourself, what makes you think that chat will help your situation? Chat always helps me. Sometimes. Some situations. Hype train complete! Level 4! Thank you. Thank you so much, Labras, for the resubs, for the gift subs. Even outside of the hype train, I'm just really, really grateful for the financial support. Like I said, I'm trying to get my YouTube monetized at the moment. We're so close. But it really is amazing to think that, like, this is my only source of income of, you know, all the of all the platforms I do. Twitch, YouTube, Threads, Instagram, TikTok. That Twitch has been my only source of income the whole time. So first time if we get YouTube odds up. We're so close to actually getting partnered and monetized, which means, like, again, it's not going to be much, but it's just nice to think that I actually get paid passively to do education. I think that's really, really cool. Am I late? Can I watch? We're taking a quick break, Victor, but you're more than welcome to come in and watch. We're going to do one more exam paper question. We're going to do one more. Okay, so everybody, we're going to get up. We're going to do some stretches, some jumping jacks. I'm going to grab a beverage. I know it's a weekday, but if I end up drinking alcohol, do not judge me. It's a bank holiday here. So technically this is Sunday for me. Today is technically Sunday. I don't plan on drinking alcohol, but if I do not judge. I'll see you guys in a little while. It's 380 joules per second per meter per Kelvin, or per Celsius, because it's delta T, not just T on its own. This means that when you subtract Kelvin from Kelvin or Celsius from Celsius, the value is going to be the exact same. Another way that heat transfers is via convection. The example I always use is a beaker of water on a hot plate. The particles at the bottom of the beaker are going to heat up and they're going to rise to the top. The cold particles at the top are going to go back to the bottom. And so you basically have a bit of a funnel going on. This is also the principle of how wind is created. When you look in a town, certain areas might heat up more than others, depending on the infrastructure, shadows, all that good stuff. And so one certain area might heat up faster than another. Heat transfers from hot to cold, and so the particles will move from the hot area to the cold area, quite literally creating wind. I don't have an equation to explain convection, and the reason is there isn't a simple equation to explain it, unfortunately. There's actually a lot of equations, and for us to truly study this field, we would have to study fluid dynamics, which we're not going to do today. And the final form of heat transfer that we study is radiation. This is basically how we obtain the energy from the sun, because as you know, via conduction and convection, you need matter for heat to transfer. Radiation doesn't need matter. And that is how the heat from the sun can transfer through space and onto Earth and heat us up and keep us warm. Power is equal to the emissivity times sigma times the surface area times T to the power of 4. Sigma in this case is Stefan-Boltzmann constant because this is referred to as the Stefan-Boltzmann equation. The emissivity value represents by how much of a black body it is. A black body is an object that absorbs heat extremely well, super efficiently, and also emits heat extremely well. Usually when we do a lot of thermodynamic calculations revolving in outer space, we assume most objects are black bodies. It makes our calculations easy. But in reality, most things are not perfect. And it's a ratio answer, so it exists between 0 and 1. A is the surface area of the object that is emitting the heat. In our case, usually it's the sun we talk about, and it emits spherically. So it would be the surface area of a sphere. T to the power of 4. Note, it's not delta T, by the way. T has to be represented in Kelvin for this equation to work. It is not good enough like in the earlier equations where we just used delta C. So it is the temperature in Kelvin to the power of 4. Most objects absorb and emit simultaneously, and so sometimes we have another equation where we have the difference of the two temperatures. The room the object is in and the object temperature itself. Then you'll be able to calculate what the net power is between the two. Here is a rough schematic of the liquid nitrogen dewar. To reduce conduction and convection, there is usually a little gap inside where there is a vacuum. If you create a vacuum, a very thin vacuum, conduction cannot occur because there are no particles to vibrate from one to the next, and convection cannot occur where a particle gets heated up and travels through air. On the outside of that vacuum, we have a silver shiny surface. Basically, we're trying to get it far away from a black body as much as possible, and usually the polar opposite of it is a shiny silver surface. This usually reduces the absorption and the emission via radiation. While a liquid nitrogen dewar operates to keep liquid nitrogen super cold, the same idea works with a thermos that is trying to keep your coffee hot inside. It doesn't matter if it's a really cold thing inside or a really hot thing inside. It is basically trying to isolate whatever temperature it is that you have inside. I hope you found that educational. What do you think, Bambi? Sound can be intense. I apologize for alarming you. I hope your ears are perked. Okay, I'll stop. Let's cover sound intensity, the decibel scale. When we study Introduction to Physics, we talk about sound being a form of energy. Specifically, we tend to measure it in terms of intensity. It's the amount of energy per second being displaced upon 1 meter squared. Hence the unit being watt per meter squared. But we want a number that is easy to reference very soft sounds, like rustling leaves and the wind. We also want it to be able to measure loud sounds, such as jet airplanes and shotguns. And so we have a logarithmic scale for human numbers, where 30-40 decibels is quiet, rustling leaves, and all the way over 150 decibels is really loud sounds, like jet airplanes, guns. The expression is beta, which is decibel, is equal to 10 log times the intensity of the sound that we're measuring over the threshold of hearing. The threshold of hearing is the minimum sound a human can hear, which is usually 10 to the minus 12 watts per meter squared. We like to use the decibel scale, especially when we're conversing normally with humans, because it's a number that means something instantly. If we're talking about intensity of sound in casual conversation, we'd be talking about units such as 10 to the minus 12, 10 to the minus 9, 10 to the minus 5, and those numbers don't mean much to people in the general public space. Although this equation seems straightforward, how would you solve it working a little bit backwards? So here's a typical problem. Imagine my classroom is operating at 75 decibels. what is the intensity of the sound in the room? 10 is just a number. It's just being multiplied on one side. So to move it to the other side, we're going to divide it. And to get rid of the log, we put everything to the power of 10. The side of the equation that has the log, it just disappears. But the side of the equation that doesn't have the log is put to the power of. In our case, that is 10 to the power of beta over 10. Rearrange the equation to find I on its own. And we have... Oh, hello. Hello, I'm back. My ponies. Oh, welcome back, everyone. Have my cup of tea ready. Oh, yeah, such good tea. Welcome back, Twitch. Welcome back, YouTubes. We are ready to rumble, and we are going to do the last pulley problem, and this is the problem I want to solve. So this is going to be the one that I make like a proper content out of, but I tried doing this by myself and I didn't solve it. So Forrester, that is a bannable offense in this stream. How dare you? How dare you? So this was last year's exam paper. I thought this was so tricky. Look at that beast. Look at that beast of a question, chat. AG. A block A of mass 8 kilograms and block B of mass, how much? 4 kilograms. There we go. I have a bit of information, and we had just got a raid. Hello, Branca. Welcome in, raiders. Meowdy friends, meowdy indeed. Welcome in. How's your World of Warcraft? Which one were you playing? Not classic, I'm assuming, but please do share. Yeah, Jimmy, that's what I asked. Welcome in, Branca. It's so good to see you. I hope you're keeping well. I hope the weather is really nice in Portugal these days. How's the pulley problems? We're solving pulley. We're on the last part. We're on the last part. So we did 2 pulley problems. We're on the last one, but it is the hardest one so far. So yeah, we're struggling with this one for sure. I'm just going to write some of the information up here for in a second. String has a all the, and then the question asks, look, I'm a WoW player. I have a vested interest. WoW hardcore? No way. 0 deaths today? That is a success. That is a success. Jesus. Hardcore is insane. The 8 looks like a 6. Fair enough. Branca has been a very, very kind supporter of this stream for a very long time. I wouldn't have made a partner without her. So huge thank you to Branca. We never get a chance to raid as much as Branca does us. It's always like that. There's a cycle of raids because, you know, you have general streaming times, general times of raiding and leaving. But yeah, huge thank you to Branca's support for getting us partner last year. Was it last year? Was it 2 years ago? How long have I been partner? It must be 2 years ago now. Damn. Also love your shirt. Thanks. It got a bit hot, so I had to take off my hoodie. It's getting a bit cold now again, so we'll see. Maybe I have to put it on again. My sister got it for me. Unless the bunny intervention kills the stream. Let's not jinx it, shall we, Spooky? Let's not. This is a hard question, isn't it? This is the problem that was given last year to the Leaving Cert exam paper. And I looked at this and I was like, what? And then there was a question of A. What is acceleration of this guy as well. That was part B of this question. I think this is a deadly question, lads. Absolutely deadly question. We have a pulley or a mass hanging at the end of two pulley systems, one string connected to all of them, by the way, sorry. And these two guys are not on a frictionless surface. Chat, hold your breath, gasp. We're actually talking about friction for the first time. Block A weighs 8 kilograms and it has a frictional coefficient of mu A. Block B has a mass of 4 kilograms and it is equal to twice that of the friction the coefficient of friction of the second object. I wonder if the first came here in a Branca raid when you were playing Clair Obscure. Oh, if you came here. So Clair Obscure, Branca supported me way before I played Clair Obscure. It was a long time ago. So Branca used to support me back in 2023, I remember. Yeah, she used to raid me a lot. Really, really nice. That's how actually I met her. She raided me once out of the blue. And that's how I got to discover her, which was really, really nice. I made a lot of friends during that time. There's just a bunch of people who rated me and supported me, and I've gotten really close with them. Branca, Slow are examples of people who just supported me blindly like that. Pathetic Wolf. There were just these awesome peeps who said, hey, you're kind of cool. Oh, good tea. I love a tea that burns my neck. Well, nothing is moving. Well, this is moving. This does move. The block moves in this direction. The block moves in this direction. This guy moves down. And so the question is, what is the coefficient of kinetic friction of B? And then part B is what is the acceleration of this block here? So that is the question of that paper. Let me pull up the question. There we go. So I have the equations here, but honestly, they're quite hard to keep track of, but at least we'll have some stuff. Looking at this, actually, it looks like solving for A might be easier first than mu B, but we'll see. We'll see. We'll do all the stuff. I refuse to answer unless I can see this moving in Blender. Fair enough. Equal weight with friction, no movement. Sure, but why would you say that it's equal weight with friction? Nowhere did I state that. Where did I say that? Tiny pulley tofu. Now we need a pulley emote just for these problems. I like that octopus. Yes, this name is Hal. Hal is our first print to test our 3D Creality 3D printer. We have a printer behind the whiteboard, an i7 that we got to test nicely. Okay, so let's do a little bit of solving here. Let's solve each part. We might draw each block as a separate diagram just to make it easier for ourselves. So the first block, A, shut up, Spooky, has a tension in this direction and has a frictional force acting in this direction. And I mean, technically, if we're drawing the free diagram, this is the normal and this is the weight. The forces up and down aren't going to do a whole lot in our system, but if we're being pedantic about drawing a free diagram, we should do that. And obviously we have the net force, F net, FA. So let's write our equation out. FA is equal to the tension in this direction, T, minus the frictional force, FFR. Okay. F net is equal to the mass times the acceleration, A, is equal to T. What is the frictional force equal to? Oh, this is a good question. You guys remember your friction forces? It might be a while. I'm currently studying for my final exam. I wish you the best of luck with it, Joy. Maybe we shouldn't be too distracted by this stream. You have mu A times the normal. And the normal is just the weight down, which is mass times gravity. There we go, a boy. A boy, a boy. So that becomes, we know what the mass is, it's 8. We don't know what the acceleration of it is, it's A. We don't know what T is equal to. Oh, we do, it's 32. I'm a liar. Sorry, I'll take it back. 32 minus mu A, we don't know what mu A is, times the mass, 8 kilograms, times G. We'll keep everything in G's for now. So there we go. We have an equation. 8A is equal to 32 minus mu A. I'm just going to double check if I'm doing something right. That's 32 A equal to okay. So what the exam paper wanted me to do was to sub in for mu B. Since the question is asking for it in mu B terms, we know that mu B is equal to mu A. Put the 2 across. That's 8A is equal to 32 minus mu B divided by 2, which means mu B. We have one important equation here. Okay. Can I use them to solve this? That would be cheating. That would be cheating. Let's look at the second problem, question 2. For the second guy. So it's a mass B. It's being pulled with a tension here, frictional force in this direction, and net force in. So FB, same direction, T, minus the frictional force. This is equal to mass times the acceleration B is equal to the tension, which is 32, minus the frictional force, which is mu B times the mass M times, there we go. So this is the equation for the next one. The mass of the second object is going to be, what is it? It is going to be 4 kilograms. So let's sub that in. 4B is equal to 32 times minus mu B times 4. Oop. I lost the lid for my marker. Oh no. If we lose the lid, it's gonna go dry. Oh dear. Oh damn. Oh damn. Damn it. That's annoying. Keep an eye on it on the floor chat. Let's print one out. Let's print a lid. Yes, yes, let's do it. We'll that in 2 seconds. Flip your lid. Let's go. Let's try it out. Okay. So I'll just double check that I have the equation right anyway before we continue. So 32 minus mu B G. Okay, I have that equation. Okay. Look at equation 1 really quick. Have a quick look at it. I'm just going to rewrite it again. A is equal to 32. It's okay. Looking at these two equations, can we see something interesting, chat? They're very, very similar. the difference between them? What can we say here by looking at these two equations? 4b is equal to 32 minus mu b 4g. B is just the acceleration of particle B. And a is just the acceleration of particle A. You're absolutely right. It's just double, isn't it? So that's fascinating. The acceleration of particle B equal to twice that of A. Very, very interesting. This is just the kind of, maybe that was a bit obvious to you about the friction part, but you know what? Now, let's look at the part of the pulley guy. So we have the 12 kg guy. It has mass, 12g down acting this way, and we have T and we have T. So equation 3 then, or story 3 that we can get out is, we're assuming, let's say it's going to move downwards, okay? So the F of particle 3, we're just going to call it particle C, just to keep it consistent with my lettering, is equal to 12g minus 2t. It doesn't matter which direction you take, as long as you're consistent, of course, with which direction you end up choosing. Exactly, it's the same thing, boy, but you just divide it by 2. So 8 divided by 2 is 4, and then 4 divided by 2. You just divide across by 4. 8 divided by 4 is 2, and 4 divided by 4 is 1. Sorry. This is the mass times the acceleration, which is A plus 2. Now, we actually got an interesting relationship here earlier. We know that B is equal to 2A. Really, really interesting aspect here. We can say mass is equal to 3A divided by 2. That's fine. That's just 3AM divided by 2 is equal to 12g minus 2t. So we have divided by 2 here. We can multiply it across just to clean it up. 3 acceleration times mass, which is 12, by the way. 12 times 3. Oh, no, let's just divide it. Fuck it. The mass is 12. 3 times 12 is 36. 36 divided by 2 is... Why don't I trust myself in this? It is 18. Okay. 18A 12g minus 2t. I'm going to take it one step further and I'm going to divide across by 2. 18 divided by 2 is 9. 12 divided by 2 is 6. And 2 divided by 2 is just 1. So 9a is equal to 6g minus t. There we go. So we have a cleaned up kind of expression here. Going to see if the exam paper has anything? No. The exam paper has nothing. Now, we can get an expression for A here. This is actually part B. We're actually kind of racing on ahead and we're solving for the second part of the question, which is fine. I'm running out of board space, but I'm just going to subtract this part here. So if we look at this equation, 9a, oh, sorry, it's taking a while to dry. Ooh. Because we have the tension, we can solve this. 9a is equal to 6g minus 32. Let's rearrange the equation to get A on its own. So in your calculators, grab them now. What we're going to do is 6 multiplied by 9.8 minus 32, all divided by 9. We get an answer of 6.24 meters per second squared for the acceleration. Now, is that right? The exam paper says 134 divided by 45, which is equal to 2.9. Oh, okay, I made a mistake somewhere. I made a mistake somewhere. Oh, I just did this again and I got the right answer. I got 134 divided by 45. And the exam paper says 134 divided by 45. So if we want it in decimal places, it'd be roughly, we'll round it up to 3 meters per second squared. So it's accelerating downwards at 3 meters per second squared in this case. So where is Bambi to save us all from this math? Hi, Solaire, welcome in. You drop the lid at the right side of the whiteboard, props on the floor. Really? Is that where I was looking for? So, working backwards, how can we calculate mu b? What is mu b is going to be equal to? That's part one of the question. Well, let's look back at, shit, I took it down, did I? No, I still have an equation here. We have this equation here, 8a is equal to 32 minus mu b for g. So we have the number for a it's 3 minus 32 all divided by 4g equal to minus mu b. I'm going to assume we're going to get a minus sign on either side. So that's 8 times 3 minus 32, we get a minus sign, it's okay, divided by 4 times g, 9.8 brackets, which is equal to minus 0.2, but there's a minus at either side. Our last answer is 0.2. Our coefficient of friction of mu b is 0.2. If we round it up, it's 0.21. And the exam paper says 0.21. And there we go, lab rats and labradoodles. We have the answer. So the pulley goes down, the mass does move down with an acceleration of 3 meters per second squared, roughly. And our coefficient of friction is 0.2. It was actually easier to solve this by solving part 2 first, the A part. And this part was really, really important. Now, you could have subbed it in really, really quickly, but because it was sorted out this way, we did solve it nicely. Very, very quick that way. I thought this question was really hard when I first saw it. I thought this was extremely challenging, going in blind, not knowing what it was what. But in the end, it's exactly the same as a normal pulley problem. We deal with these blocks instead of masses that's hanging out, that we just solve their frictions. All the forces in this side equals all the forces on the other side, or minus them, and then you have the net value, and that's the net force that it experiences. You can solve it the exact same way, but there was a friction problem associated. I thought this was extremely challenging for a bunch of 16, 17-year-olds to see for the first time. But you know what? You didn't panic. You remembered your friction stuff. Let me move this way so you guys can see a little bit better. So this is the YouTube video I want to make on. I'll do it properly. With a bit more of a guide, I suppose. 3 body diagrams, but I need a lot of board space. That's the problem I wanted to solve. Sorry, I'm getting cold again. Getting hot and then cold. We're yes, then we're no. Then add an inclined plane. Yeah, they're inclined plane problems as well. Those are also a pain in the ass to solve. Don't know if we really want to do any of those today. But that is everything that I wanted to solve today for pulley problems. We managed to solve pretty much everything I'd planned. How do you guys feel about it? For many of you, it was probably revision. But yeah, let me know if you thought that you feel much better about it, or, you know. Now let's add a spring con. I actually don't think I ever did those spring constant ones with the pulleys. I did them separately. Maybe I'm wrong, but I vaguely feel like I didn't do that before. Yeah, different materials for system A, different materials for system B. Those could be other stuff. These questions can be very, very difficult sometimes. Be very, very mean. I don't feel hunger, like I don't crave anything right now, but I feel like I'm getting the hunger shakes. I get those sometimes. Why? I eat. I had a muffin sandwich. Veggies. I ate like a couple of hours ago. I suppose it's 4:30. I'll be going home soon for dinner. No material specified. They kind of did with the kinetic friction. So they're clearly two different materials, or the tables are different, one or the other. But by defining that mu B and mu A were different, we know that they were different. Hunger shakes, time for chocolate. I love the smell of equations in the morning. Oh no. New here. Yes, Aster, I am a physics teacher, physics lecturer full time, but sometimes I stream physics stuff. Slightly distracted by work, but it moves despite A and B is equal to the weight in the middle mass then? Yes. Well, think about it. It's not the full weight of the block that's pushing it down. Let's think about it a little bit. If I had a block, okay? I had a big metal block in front of me. Is it easier for you to lift it up, or is it easier for you to push it? Pushing it is easier, right? Well, that's exactly what's happening here. It's not the full mass of the block that's stopping it. It's a push. And so we solved those things. We solved the frictional force opposing it in one direction, and we calculated what the net force of it was. It doesn't contribute its full weight. So that's why, despite the fact that this guy is 8 kilograms and despite that this guy is 4 kilograms, because they're on flat surfaces and they're being pulled, i.e. pushed, it's way easier to pull and push heavier stuff than it is to pick them up or use their full weight. So looking at that diagram and knowing that concept, you would know immediately that the weight would go down. You just had a brain workout, burned a lot of categories, burned a lot of calories. I hope so. I hope that's how it works, because I can get away with eating a lot of chocolate then. And so that concludes my Monday lesson. I haven't taught on a Monday in a long time, but hopefully I'll be able to teach a lot more. My preliminary schedule for the summer, I'm hoping, but like my summer doesn't begin until mid-June, would be Saturdays, Mondays, and Wednesdays. Because I can spend some of the weekend with Nate, but then also get some work done as well. We just did some pulley problems, Alvaro. So that's what we were solving there for a little while. If you want to watch the VOD back, you're more than welcome. But yeah, we solved a lot of problems there. Hey, Churn, welcome in.
No, thank you. We don't want any more visitors, well-wishers, or distant relations.
And what about very old friends? Very old friends indeed. I think my brain exploded. I'm sorry. I'm sorry your brain exploded. Missed most of the physics, I guess. Yeah, we did 3 hours of physics. We did applied maths exam papers specifically on pulleys. So I'm glad we solved this because I was struggling with this on paper. But I'm glad we solved this on stream. I can watch the VOD back and I'll make a YouTube video hopefully this week on it. Because I think this pulley problem is particularly cool. It's very, very interesting. There's a few
There's no ghosts in space, Frizzip!
Stop interrupting me, Frizzip. There's a few interesting aha moments. Welcome in, Frizzip. Thank you, Churn, for the resub. I really appreciate the PP points. How can we do... tomorrow's my driving test. Tomorrow's my driving theory test. I'm so looking forward to that. Yes. Very happy. Very happy, Tofu. I have to get there for so long because we do have a driving test where I am from, but I have to take a whole train to this place. It's an hour train, and then it's a 45-minute walk to the place. And I've decided to be a cheeky fecker, and I have to finish my exam in 15 minutes. Even though they give me 45, I need to finish in 15 minutes to make it back to my train. So, yeah. It's fine though, because every time I do the practice questions, I finish in 10 minutes. So I think I'll be fine. Hey, M. Subtain, welcome in. Always pleasure to contribute PP points. What even was the context of Frizzip? I was playing that weird game, Prey, and I was getting really stressed out with the spacewalk. And he used the sound alert. Ghostbusters. It was during Halloween. And yeah, I gave out to him that there are no ghosts in space to bust ghosts with. Written exam? Yeah. It's the theory test. I'm just doing the theory test. I've done it twice before. I passed both times. They're really handy and straightforward. But I still studied for it properly as well, so it should be fine. In the practice test, like I said, they give me 45 minutes, but I solved them in less than 10. But again, I'm not being careful about it. I'm flying through it. In this one, I assume I will spend 20 minutes doing it. And yeah, I'll get out of there. Largely missed those streams. I disengaged from Twitch a bit during Halloween. That's fair. That's fair. Hopefully you get a lot of gaming done during Halloween because of that. Speaking of gaming, how are you guys feeling about possibly playing some Elite Dangerous? I did download Elite Dangerous on my Steam Deck, but I did not play it. It took forever to download it. It was quite a large file. So I have not played it on the Steam Deck. So we will be launching off that pad. Oh, so close to the sun. Or the option is to play Extinction Day because we haven't played Extinction Day in a while. It was okay, Churn. So it was terrible in the beginning and I got really used to it. But now that I've left the beginner area, it's getting stressful again. No, I didn't, Debendriel. Of course I didn't. What the heck, man? Just remember to stop the car before getting out. Thank you, Jay. I will take note of that advice. Guys, down. Actually quite hungry. I don't know why such hunger right now. Thirst for knowledge. Yeah, I might eat something really quickly because I'm so hungry. Very sus. Jammy Dodgers. I don't have Jammy Dodgers, unfortunately. Did I buy anything today? I bought sour worms. That might be good. A bit of sugar. What do I feel like playing? Do I want to play Elite Dangerous or do I want to play Extinction Day? Good question. What time is it? It's almost 5. I think we'll play Elite. I think I'll do Elite instead. Yeah. All right, I'm going to go make myself a beverage and grab myself some sour worms or some biscuits. To YouTube, I say goodbye. I'll upload a proper YouTube video on this hopefully this week. I just uploaded one on maximum power transfer theorem a couple of days ago on DC, and just today I uploaded the AC one. So if you guys are interested in learning a little bit about the maximum power transfer theorem, please do enjoy, and hopefully it's supported. But other than that, good night, sleep tight. YouTube, we will see you. Twitch, do not worry. We are playing Elite Dangerous. Yes, we are. We're playing some video games. Lots and lots of video games. We'll boot up Elite Dangerous now. And yeah, we got cracking at it. I'll see you guys in a little while. I'm going to go grab stuff. Maybe pop this pimple that's annoying.